Does space-time truly hide tunnels that stitch distant stars together? Will we turn the cosmos into our own backyard, or expose frontiers stranger than any dream of light-speed flight? How long before humanity trades starlight dreams for voyages through the fabric itself? Countless stars flickered like distant lanterns, guiding curious eyes upward. In that stillness, humans felt small and connected, woven into the vast cosmos. Each shining point was a mystery and a memory, a gentle promise of something beyond our own touch. Long before recorded history, even hunter-gatherers left their mark. In caves and on rock surfaces, early peoples sometimes carved or painted swirling dots and circles. Some of these ancient markings align with the Pleiades star cluster, which returns to the sky at the time rains nourish the earth. Perhaps those early gardeners of plants and stars recognized that patterns in the heavens foretold the seasons. With soft tools and flickering fires, they filled dark caves with hints of the cosmos, as if bringing a piece of the night sky indoors. On distant hills and hidden valleys, our forebears engraved stories into stone and earth. They built circles of standing stones and pyramids pointing toward the heavens, quietly measuring the passing of seasons and time. Some carved the sun and moon and stars onto bronze discs and monuments, capturing the silent music of the sky. In those carvings and structures, the sky became a tangible tapestry, and human hands tried to hold the elusive designs of starlight. At certain times, the rising sun would illuminate carefully placed stones, casting long shadows or shining through circles carved in rock. On the winter solstice, at ancient monuments, the dawn's gold would spill over stone, a cosmic curtain call marking the year's turning point. These sunrises and sunsets were woven into rituals and celebrations. In those silent moments, people stood in awe as light and shadow played on the ancient stones, as if the earth itself were telling the story of time and light. Around 3,600 years ago, in a distant land, someone hammered bronze with sun and moon, stars, to carry a piece of the sky in their hands. That silent sky disk, glinting in torchlight, held a cosmic map in its golden hues. In its polished circle, we sense the delicate precision of early astronomers, a love letter to the night. Imagining it turning slowly beneath the stars, one feels the warmth of human curiosity, wanting to hold the sky just a little longer, to make sense of the pattern above. In one ancient city by the Euphrates, scholars labored under torchlight to map the heavens. On wet clay tablets, they traced constellations, drawing symbols that would guide generations. As night fell, their fingers barely making a sound, they recorded the cycles of Jupiter and Venus. Those delicate lines on clay were among the earliest star charts, quietly ensuring that every sunset and dawn remained linked to a pattern of stars. In that serene workshop, knowledge was passed down like a gentle flame, carried from one generation to the next. In the flickering firelight, elders passed down tales of sky deities and distant worlds. Myths were woven from the glitter of stars and the phases of the moon, as if each constellation were a character in an ancient story. In humble caves and grand temples alike, humanity's earliest artists traced the face of the cosmos, sketching its patterns onto walls of stone. Even there, in silent drawings of stars and spirals, we see the roots of wonder, the gentle curiosity that tied us to the night sky. To early eyes, some stars were more than ornaments. They were gods, ancestors, or lost friends watching over the night. Ancient astronomers read fortunes in their wanderings, charting destinies by the heavens. Even now, the night sky is a silent prayer. Echoes of those ancestors seem to whisper with every pulse of light. Amid such quiet divination, each of us felt cradled by something immense, yet familiar. These beliefs wrapped the cosmos in meaning, weaving comfort into the cold expanse of night. Sometimes a bright streak would dart across the night, a shooting star blazing trails for just a heartbeat. Early peoples often called these omens or wishes, imagining that a star had leapt from its home, carrying prayers or secrets. To watch one flash in the sky was to see the cosmos in motion, a sudden sparkle in our quiet tapestry. In those moments of awe, humanity felt seen by the universe, and perhaps whispered their hopes back to the stars that flashed and faded. As boats left their shores and desert caravans crept under the endless sky, travelers learned to read the stars like an ancient compass. Constellations became familiar friends on long journeys, their shapes guiding wanderers across silent seas and shifting dunes. Farmers watched the sunrise and the first evening star to mark the passage of seasons for planting and harvest. In this way, the heavens became a calendar and map, quietly stitching our lives to the rhythm of planets and light. The Milky Way's broad band spilled across the sky, its countless stars forming a soft glow. Some imagined it as a river of light or a bridge between worlds. Under that gentle glow, people told stories of heroes and gods traveling along the Milky Way's path. It was a highway of hope, linking our Earth to the heavens. And so the stars not only guided travel, but guided dreams, each whisper of light carrying tales of courage across time and space. In many lands, quiet observers began to chart the sky's calm orchestra. Ancient priests and sky watchers followed the wanderers, planets gliding among stars like slow fireflies. By careful counting of eclipses and solstices, they learned the secret rhythms of day and night, of seasons spinning in a gentle cycle. From Babylon's ziggurats to Mayan temples and Egyptian obelisks, people found patterns, as if the night sky were a grand clockwork. These early skyward scholars wove the heavens into timekeepers and calendars, softly syncing life to celestial rhythms. In far-flung corners of the earth, cultures separated by oceans felt the same silent pull. From African savannas to Asian rivers, people watched the same stars as their distant neighbors. Though they spoke different tongues, many wove alike stories from the night sky and built temples aligned to the sun's rise. The constellations were for all of them a shared map of meaning. Under the same tapestry of stars, civilizations recognized a common wonder, that a spark of the infinite resides in us all. A lone sailor, far from land, watches the sky through his weathered telescope. The sea is still and dark under the same stars he grew up gazing at. Even far from home, each familiar constellation feels like an old friend guiding him onward. The salty breeze carries stories of home and of worlds beyond, and the gentle sway of the boat is a lullaby. In those moments, even the ocean feels woven into the tapestry of the cosmos, each wave echoing the rhythmic pulse of the night sky. Yet even as we remained earthbound, our dreams drifted in the starlight. We felt at once tiny beneath that vast tapestry, and yet inseparable from its pattern. In those quiet hours, imagining distant worlds and adventures beyond the horizon, we wove starlight dreams deep into our stories and souls. Centuries later, a new thread of understanding began to emerge, as if a single curious mind pulled gently on one silken strand of the cosmic tapestry. It was time to discover the subtle patterns hidden in the fabric of reality. In a quieter night, many centuries later, a new dreamer, sat with his thoughts beneath the same starry sky. He studied not only its beauty, but its very nature. Albert Einstein, soft-spoken and curious, imagined riding a beam of light across the heavens. In that gentle thought experiment, he began to unravel the tapestry of space and time itself. Slowly, he saw space and time as two threads of one grand weave, each affecting the other, dancing together in a cosmic loom. He began to picture the universe as a vast fabric under his fingertips. Massive planets and stars were not just celestial objects. They pressed gently on the fabric, warping it like a hand leaving a dent in soft cloth. Light became a delicate thread, bending and weaving along those curves. In his vision, gravity was not an invisible force pulling at a distance. It was the curve of space itself, and time flowed differently in its embrace. Clocks near those dents ticked a bit slower, a gentle hint that time, too, was woven into this fabric. Einstein's vision also transformed our understanding of gravity. Planets don't travel around the sun because an invisible force pulls them. Instead, they follow gentle curves carved into space by the sun's mass. Each planet steps along its own cosmic pathway, moving serenely as if guided by an unseen hand. The solar system itself, in this view, is a pattern woven into the celestial fabric. Every orbit is a thread in the tapestry, each planet tracing its line within a grand design of space and time. Einstein went further and found that energy and mass were sewn together in this grand tapestry. A bit of mass could transform into pure light and warmth, like unwinding a precious thread from cloth and setting it shining. The warmth of the sun, the fireworks of atoms, even the glow of our bodies, all hint at threads secretly turning to light within the weave of existence. In this gentle new picture of reality, nothing moved faster than the wind of light itself, and space-time hummed to its own subtle rhythm. Einstein's dream wove on. He realized that when heavy stars spiral together, they would ripple the cosmic fabric like a pebble tossed into a silent pond. These ripples would be waves in space-time itself, traveling endlessly across the void. It was a beautiful secret of the universe. The fabric of reality could ring, humming with the faint echoes of events from distant worlds. If we listen with the right heart, even those distant tremors reach us softly, whispering of creation's enduring song. Einstein's bold insight even explained a quiet dawn light. During a solar eclipse, the moon would cloak the sun, allowing distant stars to peek out. Those star shimmers seemed to shift, ever so slightly, from their usual spots, as if the sun's gentle gravity had bent their beams of light. This was his cosmic proof. Light did not always travel in straight lines, and the unseen curvature of space held sway. In that soft twilight, science and wonder converged, revealing that space and time themselves are shaped by the sun's grace. Einstein even imagined a pair of twins in a gentle thought experiment. One twin remained on Earth, while the other set off in a swift rocket. If the travelling twin could approach light speed, their journey would feel brief, perhaps only years. But on Earth, decades might pass. When they reunited, one would have aged much more than the other. This strange outcome is a whisper of relativity. Time itself bends, so that the universe's schedule stays consistent. It was as if, in moving fast, our travellers were dancing ahead of time's tick. This effect was later confirmed in our time. Atomic clocks carried by high-flying planes tick ever so slightly slower, a gentle nod to Einstein's insight. Einstein gave us a profound new lens through which to see the cosmos. Space and time were forever interwoven, each thread influenced by matter and motion. His gentle discoveries set a rhythm to the universe, one measured by the steady pulse of light. Yet questions still lingered. If the threads of space-time have their own pace, could we ever step beyond that quiet rhythm? The speed of light had become the cosmic metronome, and as humanity continued to dream, minds began to seek ways to gently reach the stars within that woven fabric. All those revelations led to a curious boundary in our universe. Light itself travels at a fixed speed through the void, and nothing with mass can ever quite catch it. This cosmic speed limit is woven into the fabric of space-time. As an object pushes closer to that limit, its time stretches and its weight grows, demanding ever more energy. Imagine trying to outrun dawn as it peaks over the horizon. No matter how fast you run, the sun will rise at its own rhythm. So it is with light. It sets the tempo for the whole cosmos, beyond which we cannot step. At least, not yet. In the soft darkness, the stars overhead are silent storytellers. Each glimmer is not of this very moment, but of years past. A record of light travelling across the void. The constellation. Orion might be telling a tale written long ago, for its star's light took years to reach our eyes. We measure the cosmos in light years, how far light travels in a year, because even the speed of light is gentle when distances are so grand. This vastness means that when we dream of touching the stars, we must reckon with patience and the slow passage of distance. Even the sun's light seems to take its time. Each minute, sunlight races from our star to Earth, a journey of 93 million miles. Reaching Jupiter, the same beam of light wanders for over an hour. And the nearest star beyond our Sun, Proxima Centauri, lies 4 light-years away. Light takes more than 4 years to make that trip. In these cosmic stretches, patience is written into the universe's rules. Even light spends years crossing space. So when we dream of reaching new worlds, we are embracing a profound stillness. We must remember that patience is part of stargazing. Sometimes our eyes look backward in time, far into the ancient light. Even with all our technology, we move as gentle travelers. Voyager 1, the most distant human-made object, drifts at about 38,000 miles per hour. After more than 40 years, it only just reached interstellar space, the edge of our solar bubble. To reach even the closest star with such a ship would take tens of thousands of years, the span of human history repeated many times. These silent wanderers are marvels, yet beside the light-speed tapestry, they move as gently as raindrops, reminding us how long the road is to the stars. Beyond the known rules, dreamers and scientists alike have sketched shortcuts in the cosmic fabric. They speak of wormholes, hidden tunnels that might bring distant stars side by side, or of warp drives that could ripple space-time to carry a ship like a leaf on a breeze. These ideas remain ghosts at our doorstep, unproven and delicate. For now, light's steady pace holds firm as the universe's gentle law. It reminds us that every journey beyond the sun is an adventure of patience, igniting our wonder and imagination anew. For now, Einstein's light speed limit stands firm, unyielding as a mountain. But humanity's curiosity is like the ocean against the shore. It never stops pushing. If there were hidden shortcuts or new dimensions, our spirits would find them. Until then, we sit beneath the stars and accept the cosmos's quiet pace. We warm ourselves by starlight, feeling its age-old glow, and dream of ways to catch the beam. The night is patient. It teaches us that every deep question takes time. And so, we lie back and let the stars keep us company, promising that one day our efforts might reveal new paths through the celestial tapestry. In the hush of yet another night, long after Einstein's visions, humanity's dreams took new shape on the written page. Writers spun gilded tales of voyages to the stars. Jules Verne imagined travelling to the moon in a cannon-propelled capsule. H.G. Wells told of strange Martian invaders and brave sailors who might one day navigate cosmic oceans. Each story was like a thread woven into the grand tapestry of wonder, stretching our imagination further. Through their words, countless readers dared to believe that one day such voyages might not remain imaginary. Even as fiction soared, some engineers dreamed in parallel. A Russian thinker, Konstantin Tsiolkovsky, sketched out the math of rockets escaping gravity, as if the equations themselves were threads in our tapestry. In dusty libraries, early rocket scientists, Friedrich Zander, Robert Goddard, Hermann Oberth, passed those threads on, building real instruments that one day might launch our dreams. Slowly, the line between storybook and science began to blur, the warp of imagination entangling with the weft of reality. By the dawn of the 20th century, these ideas rippled outward through the ages. Pulp magazines filled with tales of interstellar voyages, rocket ships powered by anti-gravity, or by bending the very fabric of space. Writers conjured whole universes where heroes sailed from one solar system to another in a single bound. Though their stories drew on fancy, they were stitched with the same threads of wonder. Each imaginative leap kept alive the promise that the tapestry of reality could still shimmer with the possible. Night after night, families gathered by lamp or radio to hear these tales of adventure among the stars. Children drifted to sleep, imagining themselves as those bold travellers, visions of alien skies dancing behind closed eyes. The humming of an imagined rocket, the comfort of a friendly alien hand. Every simple bedtime became a voyage. In this way, the fabric of space-time expanded for each listener. The seeds of curiosity planted by these stories would blossom in later scientists and explorers, inspiring new threads in the tapestry of our understanding. Now, as this first tapestry of tales comes softly to an end, the night around us holds its breath. We have traced the early patterns of our cosmic longing, from ancient fireside stargazing to the hopeful pages of dreamers. The threads of curiosity lie waiting, ready for the next gentle touch. The stars above remain silent companions, and our minds carry their whispers onward, as the journey through the warp and weft of space is only just beginning. You drift far beyond the familiar planets, past Neptune and Pluto. The stars around you have grown brighter in the deep night, and the Milky Way stretches above like a glowing river. The silence is complete and vast. As your eyes roam this lonely void, you notice faint clouds of cosmic dust drifting between the stars. They glow softly, like gentle embers in the darkness. Even now, your craft drifts slowly, as if carried by a silent breeze on a cosmic sea. In this boundless darkness, your imagination steps forward. Even though space looks empty, it is malleable. It can stretch and fold in gentle swells. It can curl into tunnels and bridges, pathways hidden in the cosmic fabric. Imagine space as a vast tapestry, woven of threads of starlight and time. In this endless cosmos, dreams of shortcuts arise. Perhaps scientists and poets alike have imagined a secret tunnel between distant stars. Picture delicate tunnels weaving through the dark fabric. These theoretical shortcuts are called wormholes. A wormhole would be like a secret doorway connecting two faraway places in the universe. If space were a blanket, a wormhole would poke a hole through it, bringing distant stars astonishingly close. You could step through and find yourself among the stars of another galaxy, all in an instant. It sounds like the stuff of dreams, yet it comes from Einstein's vision of space-time. According to Einstein's general relativity, gravity is like the bending of that fabric. Massive stars and planets create deep curves in space. Some people imagined that if space can bend, it might even tunnel. In 1935, Einstein and Nathan Rosen wrote about a bridge connecting 2 points. It was an elegant equation, hinting at a passage through the cosmos. Later scientists called these passages wormholes, after the creature that bores tunnels. In this view, every wormhole has 2 ends, or mouths, maybe in different regions of space or even time. For now, these passages live in our imaginations and equations, hints that the universe may be stranger than it seems. Picture one mouth here near Earth, and the other mouth light years away among a cluster of stars. In theory, matter could enter one side and exit the other. However, these cosmic bridges are uncertain. They might snap shut like bubbles popping, or pinch off too quickly for anything to pass. To hold one open, it seems you would need strange negative energy or exotic matter, something like an anti-gravity glue. We don't have such material now. There are small hints of negative energy in quantum effects, but not nearly enough. For now, we treat wormholes as gentle possibilities whispered by equations. They drift softly in equations and dreams, part of the wonder of the cosmos. Wormholes remain hypothetical, beautiful ideas that ignite our curiosity. At the smallest scales, the universe is full of surprising activity. Quantum physics suggests that space-time is never perfectly smooth, but froths with energy. In this quantum foam, tiny wormholes might briefly wink into existence and vanish in a heartbeat. These microscopic tunnels would be far too small and fleeting to traverse or even detect. They are like brief raindrops on the fabric of space, hinting that the cosmos is alive with hidden structures at every level. To see this in simpler terms, imagine drawing 2 distant stars as points on a sheet of paper. If you fold the paper so that the 2 points touch and then poke a hole at that spot, you've connected the stars with a tiny tunnel. In that moment, the huge distance disappears. A wormhole works similarly, but in 4-dimensional space. By folding the cosmic fabric, 2 far-apart regions become adjacent. You could step through the folded space and come out the other side immediately, as if taking a shortcut. It's as if, on your cosmic map, 2 distant galaxies snap together and you could walk from one to the other through a new door. That folding is invisible to you. You only feel the instant crossing from here to there. If a wormhole could stay open, a journey through would be unimaginable. The entrance might look like a shimmering portal of light in the void. Stepping through could feel like drifting between worlds. You might sense only a gentle tug, or possibly nothing at all, as reality shifts under your feet. One moment you see Earth's sky, the next you see alien stars. It would be as if a doorway in the cosmos opened beneath you and carried you off. The stars and sky around you would be instantly different, as if teleported in a breath. In that serene instant, you might take a gentle breath, then realize you have arrived somewhere entirely new. The sky above you would be different, perhaps two suns on the horizon, or unfamiliar constellations. Nothing about the moment would startle you. It would feel like the cosmic tapestry has slowly and quietly rearranged itself. And then, as you step fully through, you find yourself in a place where even reality itself seems changed. Of course, all this is speculation. Wormholes have not been discovered. They exist as solutions to the equations of general relativity, not as objects we've ever seen. Even the idea of stepping through raises questions. Some calculations suggest such tunnels might let time twist as well. Going in one end might land you in the past or future of the other. That sounds like a paradox, but for now, let us simply smile at the puzzle. These strange possibilities drift past like distant clouds on the cosmic horizon. For our journey through ideas, we keep this wonder lightly, like a faint constellation on the edge of our knowledge. In the quiet of deep space, the tapestry of the universe invites you onward. You have explored the idea of wormholes, a kind of cosmic shortcut through the fabric. It's a path at the edge of science and imagination, where physics and dreams entwine. As we gently let this idea settle, the tapestry remains whole, and we turn to another wonder. What if, instead of stepping through a tunnel, you could ripple and reshape space itself? The journey continues with new ideas of bending reality. The next idea you encounter is like a gentle boat riding cosmic waves. Your spacecraft sits quietly, as if on a placid ocean of dark, star-speckled sea. Instead of a distant tunnel, imagine this vessel carries its own patch of space around it. This notion was proposed by physicist Miguel Alcubierre. He imagined a warp bubble that could carry a spaceship across the galaxy without the ship itself moving through space in the usual way. Here, space is like water under a boat. The boat glides forward with the wave, even though from its own perspective it hardly moves at all. In Alcubierre's vision, the spacecraft sits in a bubble where the rules of motion change. Space itself contracts in front of the bubble and expands behind it. The ship inside feels no motion or force. It is cocooned in a calm pocket of spacetime. It's as if the bubble rides a wave of curved space, slowly bending the cosmos around the ship. As you imagine it, the ship itself rests motionless, like an autumn leaf floating on a gentle stream, while the stream of space carries the ship forward. To anyone inside, it would feel completely normal. No bump, no rush of acceleration, only the quiet, steady forward motion of space itself. In this vision, the craft would travel faster than light relative to the outside universe. Yet anyone inside would feel no acceleration at all. Inside the bubble, everything is quiet and still. Stars outside might blur or shift, but you and your ship would feel as peaceful as if you were resting at anchor. There is no roar or jolt, just a smooth glide. Space-time itself is like a gentle ocean wave, and you are surfing on it, softly cradled in the moving water of the cosmos. Creating such a bubble requires exotic energy and negative pressure. These terms sound strange and mystical. Negative pressure is like a cosmic tension that pulls space inward. Physicists call it exotic because it doesn't behave like everyday matter. To hold open a bubble of space, one might need something like anti-gravity glue. We don't have readily available sources of negative energy, but the equations say it could hold the bubble open. Think of it as the cosmos, helping to lift and push the bubble along. You may recall how waves carry surfers across the sea. Similarly, this negative energy could ride on the wave of space. While we have not built a warp drive, the equations allow it. It feels like science fiction built on real equations, where the universe's fabric is flexible. In our imagination, this floating space bubble is as gentle and silent as a boat drifting in a still harbour under starlight. If such a bubble were real, what would it look like? Inside the bubble, you would see familiar stars fade and stretch. Ahead, the stars might crowd into a bright ring, like looking through the mouth of a tunnel of light. Everything ahead would converge, as if the universe were narrowing in front of you. The journey would be astonishing. While inside your bubble time flows normally, the scenery outside would rush by. Worlds and nebulae might fly past outside the window, while inside the cabin, time feels unchanged. You could cross light years in what feels like moments. Yet for now, we know only how to imagine this bubble. Even so, the image of space bending like a soft cloth is reassuring. You would ride on space itself, rather than fighting through it. There is a deep calm in the idea of drifting with the currents of space-time. The warp concept is like a lullaby of physics. It suggests the universe may be more flexible than it first appears, capable of gentle curves that carry you forward. Imagining this calming voyage helps settle the mind, as though the cosmos itself is gently supporting your journey. All ideas have puzzles. The Alcubierre idea whispers of distant voyages, but it also has unanswered questions. The energy required for this cosmic swell could be enormous, perhaps more than what a star produces. The edges of the bubble might glimmer or radiate in mysterious ways, perhaps brightening the void like a ghostly wave crest. These are technical details that experts ponder, but for our adventure, they remain distant concerns. We note them like ripples on a pond's far edge, leaving our immediate course smooth. For our quiet journey, we note these puzzles and let them float by without heavy concern. We keep the mood calm and curious. The vision of a warp bubble remains one of serene travel in our imagination. It is enough to think of space itself as a moving river carrying you on a gentle current. The uncertainties are simply part of the mystery, like minor waves far away, not choppy waters beneath our keel. Now, as you rest on this imagined bubble, you also become aware of another kind of thread in the cosmos. As one kind of connection carries you across space, another weaves through the fabric of reality. Imagine if even the tiniest bits of matter could connect instantly across any distance. This brings us to a new idea: quantum threads, the entanglement of the very small. Imagine two particles born together, like identical twins who start side by side. After birth, they are carried away on separate currents, one drifting to a star in the northern sky, the other to the opposite edge of the cosmos. Despite their distance, a mysterious tether ties them together. If you gently nudge one of the pair, the other feels it at once, as if through an invisible thread of awareness. Albert Einstein found this notion so strange that he called it spooky action at a distance. But experiments have shown it's real. In peaceful laboratories on Earth, scientists now routinely weave such quantum links. With carefully aligned lasers and mirrors, they prepare pairs of particles, often photons of light or even electrons, with this invisible bond. In one experiment, two entangled photons shared between two buildings mirror each other perfectly. Change the spin of one atom, and its twin light years away would reflect that change the instant you measure it. It's as though the universe shared a secret between them. What can you do with this cosmic connection? In our gentle story, you might imagine sending messages instantly. In reality, we still need another step to use it fully. Yet researchers have become clever. They've built small quantum networks linking particles in the same lab, then across different rooms, and even between distant cities through optical fibers. The possibility of quantum teleportation has become real in laboratories. Scientists have teleported the exact quantum state of photons and atoms over kilometers in experiments. This doesn't move matter, but it means the information defining one particle can appear instantly in another. The notion of teleportation here is very specific. It means transferring the exact quantum state of one particle to another, using the entangled link and a small classical message. Think of it as a secret handshake. First, the entangled particles are shared, the key. Then a tiny normal signal unlocks the information. It's like sending a locked treasure chest by regular mail, then instantly teleporting the key across space. Only when the key arrives can the chest be opened and its contents revealed. No mysterious superluminal transport of matter happens, just an instantaneous sharing of information, as if the distant particle becomes the original. This all hints that the universe may be threaded in ways we do not fully understand. It is as if entangled particles whisper to each other across the emptiness, connected by a hidden web. Imagine two lanterns glowing in perfect unison on opposite sides of the galaxy, or two hearts beating in sync on distant worlds. Everything appears part of a grand cosmic weave. The universe suggests that nothing is entirely separate. Even the tiniest speck of matter can feel another speck's touch through this cosmic web. It may not whisk you physically across the stars like a ship does, but imagine lying back and sensing the universe as a web of resonance. Each moment you sit on Earth, your mind could feel a ripple from a star light years away. Picture reaching out in the dark and touching the unseen threads that connect everything. The sensation is subtle, more like knowing than seeing. In this way, even the vast emptiness feels less lonely when you sense the gentle connections woven through it. Some dream that one day we could harness these quantum threads to weave a true cosmic internet. Secure communications and instantaneous links might become possible. Early experiments on Earth already link quantum devices in different cities, and satellites are sharing entangled particles across hundreds of miles. The building blocks of a quantum network are taking shape. For now, it's enough to marvel at this hidden web. These entangled partners are like perfect twins, carrying the memory of each other across space and time. For our calm journey, we simply acknowledge their existence and the wonder they bring. We drift with their mystery and let their secret handshake hang in the air. They are gentle companions on our path, reminding us of how deeply connected the universe is. With this understanding, let the notion of instant links settle in your mind. Your thoughts slowly wander from the smallest particles back to the larger picture. The fabric around you might have more layers than you ever suspected. If the universe weaves such threads at its tiniest level, perhaps it hides extra dimensions beyond what we see. On we glide, curiosity unfurling as we peer into these hidden depths. The next idea lies in those dimensions. Imagined worlds curled away from sight, the fabric itself folded and folded into unseen directions. Think now of extra dimensions, hidden depths of the cosmic tapestry. Imagine if the universe has more directions than those we see. In a two-dimensional flatland, creatures could only move along a plane and would never notice a third dimension sticking out. In our three-dimensional world, we might be similarly blind to higher dimensions. Some theories suggest just that. Our cosmos could have many hidden dimensions folded into its fabric. These extra dimensions might be curled up so tiny or woven in such complex ways that we simply can't perceive them. They may be real in the mathematics, like length and width and height, but invisible to our senses. Think of a garden hose lying on the grass. From far away, it looks like a one-dimensional line. But as you approach, you see the hose is actually a tube with an extra circular dimension at each point. In a similar way, the universe might be like that hose. Its extra dimensions are tiny circles or other shapes too small to notice from our 3D perspective. If you were a tiny ant on the hose, at first it would seem like just a line, but soon you'd realize you could also walk around the tube's circumference. We may be like that ant, unaware of an extra way to move through space. Physicists have proposed around 10 or 11 dimensions in some models, all as real as length, width, and height, but simply unseen. In string theory, for instance, the extra dimensions are thought to be compactified into shapes called Calabi-Yau spaces, swirling too small for us to see. Some ideas even suggest these dimensions contain parallel universes, neighboring like sheets of paper. If that were true, stepping through an extra dimension might be like sliding off one page onto the next. You could travel to places otherwise unreachable by just moving through our 3 familiar directions. If you could actually move into one of these extra dimensions, distances in our world could shrink. Those hidden directions could act as secret shortcuts. Imagine 2 points on a table. Ordinarily, you travel across the table to go from one to the other. But if the table had a hidden fold into another direction, you might simply step off the edge and pop up at the other point. In fantasy terms, this is like stepping off the map of the galaxy and walking to a distant star by moving through an unseen bend in space. Such moves are purely hypothetical, but they stir the imagination of what might lie beyond our direct view. These ideas are very abstract, mostly mathematical for now. We have no way to directly see higher dimensions at present, but they elegantly help unify our understanding. Extra dimensions might fold together all the forces we see. As you gently contemplate this, you carry a sense that the universe might be more intricate than our eyes suggest. The cosmic tapestry could have more threads, some hidden just out of view. Now, we let the thought of these hidden dimensions fade, and we turn our attention to time itself. If space conceals secret doorways, time may hold its own surprises. We slowly drift toward the most puzzling idea of all, that bending space could knot and loop time. Our journey now explores these temporal paradoxes, those tangled threads that come with dreams of faster-than-light travel. Time in the cosmos is a delicate thread, woven into the fabric of space itself. According to Einstein's relativity, time and space are intertwined. When we imagine traveling faster than light, time itself may start playing tricks. In theory, if you exceed the cosmic speed limit, you could arrive before you left. It's like jumping ahead of your own shadow. This sounds like a paradox. A traveler might go back and prevent the journey they took. Perhaps you would slip into the past and erase the very path that brought you to this moment. If the effect happens before the cause, the fabric of reality could become tangled beyond easy repair. One famous example is the grandfather paradox. Imagine you travel to the past and meet your grandfather as a young man. If you were very unlucky and accidentally kept him from ever having children, then you would never have been born to make that trip. Suddenly, your own existence becomes impossible. How can your future travel happen if you cease to exist? These puzzles feel like knotty threads in the cosmic tapestry, forcing us to question whether time allows such loops. There have been many suggestions to resolve these questions. One idea is that the universe has built-in safeguards. Perhaps whatever happens, it always balances out so that history remains consistent. In that view, any action you try in the past was already part of history all along. If you reach back to change something, your actions were already woven into the timeline from the start, preventing any contradiction. In other words, the story is self-consistent. You simply end up fulfilling history rather than altering it. Time would bend around itself to protect the grand design. Another concept comes from the idea of many worlds. What if traveling back in time creates a new branch of reality? In that case, stepping into the past might carry you into a parallel timeline. You could then alter events in that other world while your original timeline stays intact. It's like creating a new thread in the tapestry instead of unpicking the old one. You would not erase your existence. You would merely weave a different pattern on another loom. Each action could spark a separate universe, removing any paradox from your own history. No one really knows which, if any, of these ideas describes our universe. Some physicists even doubt that faster-than-light travel can happen at all because of these thorny issues. Stephen Hawking once quipped that the lack of time-traveling visitors to the present might be evidence that time machines will always remain impossible. Perhaps nature has a law, sometimes whimsically called a chronology protection principle, that prevents paradoxes before they happen. Even without traveling to the past, simply moving faster than light could scramble cause and effect. In relativity, if information or objects go superluminal, two observers might disagree on the order of events. An effect could be seen before its cause. Imagine sending a message to yourself in a loop. The end of the message could arrive before the beginning was sent. It's like a snake eating its tail, forming a closed loop of time. Scientists call these solutions closed time-like curves, and they are riddles that arise from bending space and time. We should remember that these are currently just thought experiments. We don't have time machines to test, and perhaps some unknown principle or new physics would prevent paradoxes from ever occurring. For now, in our gentle exploration, we simply acknowledge the puzzles and carry on. We do not try to untangle them fully. We only feel their presence as ripples on the far edge of understanding. In the end, whether or not we can ever travel faster than light or slip through time, these ideas connect us more deeply to the cosmos. The warp and weft of space and time remain beautiful and mysterious. As you continue to imagine, allow yourself to rest in the wonder of it all, cradled by the endless tapestry of the stars. In the quiet halls of research, physicists at play begin to craft warp engines on paper, their thoughts unbounded by practical constraints. Here, a warp drive exists not as a completed machine, but as a tapestry of equations and visions. Researchers take pencil to paper or fingers to keyboard, weaving new geometries of space-time. They draw on Einstein's theory of relativity, bending and stretching space on blackboards. One of the most famous ideas is the Alcubierre warp bubble, a solution discovered in 1994 in which space itself expands behind a spaceship and contracts in front of it. On paper, a starship might exceed the speed of light by surfacing such a bubble. These sketches, diagrams and formulas are playful yet profound. In the safe realm of theory, Researchers can imagine the impossible, a drive that moves without motion, gravity fields reversed, space and time inverted. Each idea is carefully grounded in physics, but in this creative space, leaps of imagination are allowed. Other theoretical engineers propose their own forms of warp drive, exploring different shapes of bubbles or methods of warping space. Netario's version without energy flow, or constructs involving extraspatial dimensions. In these pages of scribbled math, the impossible begins to look almost real. Yet even drawn on paper, a gap remains. Each of these equations calls for a fuel that does not yet exist, a kind of exotic matter, or energy, that lives only in theory. To bring a warp engine closer to reality, physicists now turn to the question of fuel. What power, or particles, could possibly make the impossible possible? Among these researchers, names like Miguel Alcubierre and José Natario have become almost legendary. Their mathematical toy rockets inspired many others. Today, a new generation of physicists keeps playing with the equations. They explore all sorts of warp metric designs. Some tweak the shape of the bubble. Others adjust how rapidly space expands behind the ship. One group even proposed shrinking the bubble to make it more efficient. In each case, the idea is the same. Keep the starship safe in flat spacetime, while letting space itself do the moving. All of this work happens on paper, or on computers. But science often begins this way, with scribbles on blackboards and simulations on screens. It's imaginative play, yes, but anchored in math. As long as they obey Einstein's rules, even the wildest ideas help us see what might one day become possible. These ideas have even spurred real meetings of the minds. Engineers and dreamers sometimes gather to discuss warp drives together. For example, a conference organised by the British Interplanetary Society drew together physicists, engineers, and even science fiction writers, all curious about faster-than-light travel. Their motto is, from imagination to reality, and that spirit was on full display as participants shared their sketches and equations for warp engines. Even if the machines are only on paper, such collaborations help bridge the gap between wild fiction and serious science. In everyday engines, fuel is something familiar. Rockets run on hydrogen, cars on gas, batteries on electricity. But for a warp drive, fuel means something far stranger. Most warp theories require a type of negative energy density, exotic matter with unusual properties. Put simply, a warp field needs regions where space is pulled apart instead of compressed. No ordinary substance does that. Empty space itself might hold the key. The vacuum isn't empty, but teeming with fluctuating fields, and these sometimes produce tiny pockets of negative energy. One famous example is the Casimir effect. When two metal plates sit extremely close together, their quantum fields intervene to produce a tiny negative pressure between them. If engineers could amplify or harness such effects, the energy of the vacuum itself might power a warp bubble. This is no longer fuel in a tank, but energy drawn from the fabric of space. At first, this sounds like magic, but nothing in the math forbids it. Physicists sometimes posit objects with negative mass, which would behave as if repelling normal matter. Even dark energy, the mysterious force causing the cosmos to expand, is a kind of negative pressure on cosmic scales. Some theories even suggest exotic particles or fields, like hypothetical tachyons or phantom energy, that always have negative energy. If any such entities could be created or harnessed, they might power a warp drive. But all these remain speculative. None have been produced in reality or fully understood. For now, these ideas live in theory and in a few daring experiments. In laboratories on Earth, teams now experiment with exotic setups. For instance, one team used complex Casimir cavities, microscopic structures that enhance vacuum effects, to hunt for warp-like distortions. In 2021, researchers led by a former NASA physicist reported seeing a minuscule warp bubble on the scale of nanometers. It was incredibly small, yet if confirmed, it hints that negative energy densities might indeed be manipulated. This does not mean a starship is around the corner, but even a tiny bubble of warp shows the principle may not be purely imaginary. In truth, this is an incredibly modest result. A real starship would need unimaginably more energy. Yet even tiny hints are taken seriously. Today, these forms of exotic energy remain largely theoretical and elusive. But the fact that experiments can even approach such conditions shows how far curiosity has taken us. With each experiment, we learn a bit more about nature's extremes, keeping alive the dream that one day, exotic matter might power a journey beyond light itself. Interestingly, some recent work suggests negative energy might not be absolutely necessary. In 2024, one team proposed a warp bubble using only conventional positive energy matter. Their design created a region of curved space that could propel a spacecraft to speeds approaching, but not exceeding, light speed. It doesn't break Einstein's rule, but it still bends space-time in novel ways. Their work shows that with clever geometry and fields, we might someday engineer warp-like effects using only normal physics. It's an early result, far from a working engine, but it encourages the idea that even ordinary matter could help in this endeavor. In one experiment at NASA's Johnson Space Center, a physicist set up a special interferometer test. He passed a laser beam through a high-voltage ring of capacitors, hoping any warp bubble would change the light's path. Early on, the team reported a tiny difference between the charged and uncharged states of the device, but the effect was buried in noise. It remained inconclusive. Even with improvements, no definitive signal emerged. This was like trying to hear a pin drop during a thunderstorm. Nevertheless, the experiment pushed technology to its limits, teaching us how space-time might behave under extreme conditions. Each null result is a lesson in humility. Warp effects, if they exist, will be remarkably subtle. Look again at the night sky. The universe itself is slowly expanding, driven by a mysterious force that might be the ultimate warp fuel. Distant galaxies are carried apart by this dark energy, which acts like a gentle, constant push on space. In effect, space itself is performing a sort of warp drive on a cosmic scale. If one could harness even a fraction of that force, it could feed a warp engine. For now, humanity only measures this expansion through telescopes. We do not know how to control it. It is as if we watch the wind stir the ocean and hope to catch a breeze to sail the stars. But this cosmic expansion reminds us that the fuel for faster-than-light travel could be written in the fabric of the universe itself. For now, scientists push these ideas as far as they can on Earth. Laboratory experiments are exploring the smallest scales, while telescopes look for cosmic clues. We continue the quest by turning our gaze skyward, searching the universe itself for any hints of warp-like phenomena. If the cosmos holds answers, in the form of strange gravitational signals or exotic cosmic events, we will find them. Our journey has only begun, and the next step is to look beyond our laboratories into the depths of space. While Earth-bound researchers ponder how to create warp power, astronomers peer outward, asking if the sky itself might betray secrets of faster-than-light travel. If warp engines ever exist, they could leave telltale marks on the cosmos. Astrophysicists now propose ways to search the heavens for such signs, blending scientific rigor with imagination. One idea focuses on gravitational waves. If a warp bubble appeared or collapsed, it might send ripples through spacetime. In 2024, a team of theorists ran simulations of a collapsing warp bubble and found it would produce a distinct burst of high-frequency gravitational waves. Unlike the gentle chirps of merging black holes, this signal would be a sharp, unusual blip. Current detectors, like LIGO or Virgo, aren't tuned to such frequencies, but future instruments could be. Listening for this unique signature means the universe itself might broadcast the echoes of warp technology, if it exists. Astronomers also consider the effect on light. A warp bubble bends space, which could distort background starlight in unusual ways. In principle, a star's image might flicker, smear, or shift if a warp-driven ship passed nearby. Large surveys and sky maps are now sensitive to tiny lensing anomalies. No such odd distortions have been confirmed yet, but data is combed for anything unexpected. Even the precise ticking of pulsars could hide clues if a warp field drifted through our line of sight. The search even extends to exotic particles. Some speculate a warp engine might emit bursts of high-energy particles or neutrinos. Telescopes and detectors that scan for gamma rays, cosmic rays, or neutrino flashes could, in principle, catch a transient signal with no known origin. These ideas are far-fetched, but they illustrate the length scientists will go to test the impossible. By considering these possibilities, researchers ensure no cosmic whisper is overlooked. So far, the night sky has offered no proof of alien warp technology. This silence is itself a kind of data. It suggests that if warp travel is happening, it's exceedingly rare or subtle. Even without finding a smoking gun, this hunt guides us. It highlights what to look for, how to improve our instruments, and how to refine our theories. In the end, listening to the cosmos for the unexpected can only deepen our understanding of the universe, warp drive or not. For decades, stories have imagined warp travel, from pioneering writers to blockbuster franchises. These tales aren't mere fantasy. They ignited real scientific curiosity. Now the line between fiction and research blurs. The same people who once loved tales of interstellar voyages now study the math behind them. This playful dialogue pushes both sides forward. Scientists double-check theories against narrative, and writers polish fiction with the latest science. To see how reality inches closer, some draw analogies. One proposal compares warp drive's progression to the centuries between moon myths and moon landings. Early letters imagined lunar voyages in the 1600s, and Apollo came about 300 years later. Fictional warp drives started appearing about the 1930s, and one estimate places a working warp engine in the 2180s. Today, we might indeed be in the early speculation stage of that journey. It may all be a distant dream, but it frames progress as a long process. Bold ideas sown in fiction, nurtured by science, and perhaps harvested centuries later. Engineers and physicists even note the need for common language. In one story, an engineer quipped that to build a warp drive, Spock and Scotty must speak the same language. Real teams find that true. Different specialties develop their own jargon and units, so clear collaboration is vital. Academic papers now describe warp metrics in ways that engineers can parse. This small bridging of discipline is another step toward reality. Both science and fiction benefit from this exchange. NASA's advanced propulsion programs and private think tanks grant out funding for speculative studies. Science fiction writers follow these developments closely. Meanwhile, conferences on future spaceflight sometimes include talks on warp concepts. As stories inspire experiments, experiments refine stories. Each feeds the other, fueling public imagination and professional motivation. This synergy is part of the warp drive's tapestry. Through it all, the notion of warp drive remains a shared dream across fields. There is no single path from theory to starship. It is a long road of many small steps. But the fact that conversations are happening at all, between labs and creative studios, is a hopeful sign. One day the fiction of today could be the science of tomorrow, if these threads keep weaving together. Even without building one, engineers have sketched what a warp-capable starship might look like. A common vision is a sleek silver craft with large toroidal rings or nacelles encircling it. These rings would house the warp field generators, shaping space around the ship. This design echoes classic science fiction art, but it's grounded in real physics proposals. The symmetry helps keep the bubble stable. The rings' spacing and size are tuned to the warp equations. While entirely speculative, such images remind us that if a warp drive is ever built, it might look surprisingly graceful. In these concept designs, the crew cabin sits in a central pod, safely encased away from the most extreme fields. Around it lies the ring structure, engineered to handle exotic forces. Engineers imagine these rings filled with superconducting coils, perhaps powered by ultra-bright reactors, generating the intense fields needed to warp spacetime. Illustrators and scientists together sketch thick containment walls and support struts, hinting at the functions, heavy power lines, cooling systems, and the field emitters themselves. The drawings may seem artistic, but they convey the idea that such a craft could, in principle, be assembled by advanced technology. Powering a warp drive would require energies far beyond today's rockets. Designers often include futuristic power plants in their schemes. One idea is a powerful fusion reactor feeding into the warp coils. Another imagines harnessing matter-antimatter annihilation through controlled reactors. Some speculative drawings even show banks of capacitors or energy storage rings surrounding the engine. None of these exist yet, but the point is clear. Any warp-capable ship would need a staggering energy source. It might involve multiple generators working in tandem, plus onboard computers to constantly adjust the geometry of spacetime in real time. Steering and safety also shape the design. A warp-driven ship wouldn't maneuver like a normal spacecraft. To change direction, the ship would tweak its warp bubble, almost like tilting a surfboard on a wave. Astronauts might pilot it by modulating the bubble's shape around them, rather than firing thrusters. Inside the bubble, the crew might feel like floating peacefully, experiencing almost no acceleration. In fact, the idea is that passengers would never sense being at warp at all. The universe itself would flow around them toward their destination. Still, many questions remain unanswered by these daydream designs. How exactly to create the bubble and then switch it off? What materials could contain such fields? How to protect the crew from cosmic rays while zipped between stars? Engineers draw blueprints and sketch layouts, but they also note the uncertainties. Each design exercise exposes another challenge. Yet even though we may not know the answers now, the process of design pulls the warp drive closer to reality. Each blueprint is a step forward. It tells us what new physics or materials to discover and what engineering feats to attempt. The warp drive spacecraft remains a dream on paper, an icon of human imagination and engineering aspiration. But dreams have power. Each sketch and calculation is a thread in the tapestry of our future exploration, and with those threads still being woven, our journey through the warp and weft of space continues forward, toward whatever lies beyond the horizon. Imagine a day in the future when a human starship lands on a new world orbiting a distant sun. the hatch opens, and explorers step out onto alien soil. Now imagine they discover that this world is not uninhabited, that beneath an amber sky, a community of intelligent beings is watching these newcomers with curious eyes. In that pivotal moment, the fate of two civilizations could hinge on our choices. Do we come as friends, in peace, seeking mutual learning? Or do we act as conquerors, claiming territory and resources for ourselves? The ethical path we choose would speak volumes about humanity's character, and it would likely set the tone for all interactions to follow. Even without meeting aliens, simply expanding our own presence into space raises profound moral questions. Up to now, all of humanity lives on one planet, governed by many nations and laws. But once we establish outposts or colonies on other planets or moons, how will we govern them? Will they be extensions of earthly nations, subject to the old rivalries and hierarchies? Or will we forge new, more unified ways of managing our affairs? And who gets to decide who can settle a new world or exploit its resources? Our history offers both cautionary tales and hopeful precedents. During the age of exploration on Earth, when seafaring empires reached new continents, the encounter between cultures often turned violent or exploitative. Indigenous peoples were frequently brushed aside, or worse, as imperial powers planted flags and pursued wealth. We look back on those times with regret, recognizing the injustice and loss that occurred. As we look forward to becoming explorers of the galaxy, we carry the weight of that history. We have an opportunity to avoid repeating those mistakes on a cosmic scale. The key will be remembering that discovering a place doesn't mean it belongs to the discoverer, especially if someone is already there. One encouraging sign is that even before humanity had the capability to send people to other worlds, we began establishing principles for ethical space conduct. The Outer Space Treaty of 1967, an international agreement, declared that outer space and celestial bodies are the province of all mankind, and that no nation can claim sovereignty over the moon, planets, or space itself. In essence, it established that space should be a realm free of earthly territorial disputes, used for peaceful purposes and for the benefit of all. This was a remarkable commitment, essentially saying, when we go out there, we leave our flags at home. Of course, writing principles is easier than living by them. If Mars or some distant asteroid belt becomes home to thousands of people, will the same spirit of cooperation hold? Or will new forms of competition and inequality take shape off-world? Consider the scenario of a colony on Mars a century from now. If that colony is founded by an Earth-based entity, be it a government or a private corporation, what rights will the colonists have? History on Earth suggests they will eventually demand self-determination. We might recall how colonies on Earth, once they grew self-sufficient, often sought independence from their distant rulers. Will Martians one day debate their political separation from Earth? And how would Earth react to a desire for independence on a world millions of miles away? Such questions might seem fanciful now, but they may become very real if our species establishes multiple footholds beyond our home planet. Planning for fairness and autonomy in advance could prevent conflict later. Perhaps a new framework will emerge, something like a federation of planets, where each colony or world has representation and a say in collective decisions, rather than being controlled unilaterally by Earth. Now imagine another situation. We find a planet teeming with life, but that life is not intelligent in the human sense. Perhaps alien forests flourish and strange animals roam, but there's no society or technology. Is it ethical for us to terraform such a planet, alter its environment deliberately, to make it more Earth-like for our own settlement? By doing so, we might extinguish native species or irrevocably change the natural balance of that world. Some would argue that if there is no intelligent life, it's fair game for human use, especially if it could become a new home for our expanding population. Others would contend that we should treat alien ecosystems with the same reverence we try to accord Earth's own biosphere, protecting them as we would a rare wilderness. The decision likely would come down to our values and perhaps our level of need. If humans are desperate for a new home, the pressure to terraform might be intense. But even then, could we find ways to preserve samples of the original life, or to confine our habitation to certain regions, minimizing harm? These are the kinds of ethical puzzles that future generations might have to solve. The question of encountering alien intelligence brings an even greater ethical dimension. Let's say those beings watching our explorers from behind the trees of that distant world are technologically primitive compared to us, perhaps living in villages with no machines or modern science. In that case, we would suddenly hold all the power in the situation, and the potential for unintended harm would be enormous. Introducing advanced technology or ideas could disrupt their society and culture in ways we can't predict. History again offers parallels. When technologically advanced societies met more isolated ones on Earth, even well-intentioned interactions often brought disease, cultural disintegration, or exploitation. Many in our current world believe that if such a situation arises in space, the kindest thing might be to follow a policy of non-interference, at least until the indigenous civilization reaches a level where contact can happen more as equals. This is essentially the prime directive concept beloved in science fiction, a rule that forbids interfering with the natural development of alien civilizations. Following it would require restraint, patience, and a kind of humility, recognizing the right of another people to chart their own course without us playing the role of gods or saviors. But non-interference has its dilemmas too. What if those alien villagers are suffering from a disease that our medicine could cure easily? Would it be ethical to withhold aid in the name of not interfering? What if they ask for help? On Earth, we struggle with similar questions when uncontacted or isolated human groups are concerned. There are no easy answers, and each scenario might demand its own careful calculus of harm and benefit. The core principle would likely be respect. Respect for their autonomy, their culture, and their well-being, balancing that with our own values of compassion and solidarity. The potential for conflict cannot be ignored either. Perhaps we encounter another spacefaring civilization, one as advanced as we are, or more. Now the ethical question broadens to a diplomatic or even existential scale. How to coexist without violence, how to establish trust. If resources are abundant in space, maybe there's little to fight over. But if, for instance, both we and they covet the same habitable planet or the same source of rare minerals, will we be able to negotiate a fair sharing? Or will greed and fear drive us to confrontation? Will we be able to see an alien species as fundamentally having equal rights to life and liberty as our own species? These are ethical as well as practical questions. The hope is that by the time such a meeting occurs, we will have matured enough as a civilization to handle it peacefully. International cooperation here on Earth might be a training ground. If we can learn to resolve our global problems without war and with justice, we'll be better prepared to do the same on an interstellar stage. Within our own species, as we spread to multiple worlds, another ethical challenge will be ensuring that basic human rights and dignity carry through the void. Distance can dehumanize. It might become too easy for people on Earth to see those in a far-off colony as out of sight, out of mind, and vice versa. Maintaining empathy and unity across the spans of space will be difficult. Regular communication will help, but even communication might be delayed by light years if we don't have FTL communication. Societies could drift apart, and misunderstandings could grow. We might need new norms, and perhaps new kinds of ceremonies or exchanges to bind together communities light years apart. Education will likely play a role, instilling in each generation, whether born on Earth, Mars, or a spaceship en route to Alpha Centauri, the idea that all humans are part of one extended family. If we fail to do that, we risk a future of fragmentation, where prejudice could arise based on planetary origin. Imagine people from Earth looking down on Martians, or vice versa, in the way inhabitants of one nation have historically demeaned those of another. Commerce and resource use in space also raise ethical points. Who gets to mine the asteroids for valuable metals? If a private company does it, do they own those resources outright? Current international law says no celestial body can be owned, but interpretations are evolving as commercial space activity grows. Some argue that allowing private enterprise to profit is fine as long as it doesn't deprive others, while others suggest that space resources should be considered the common heritage of humankind, perhaps with some kind of sharing mechanism in place. Striking a balance between encouraging exploration and innovation and preventing a gold rush-style scramble that could lead to conflict and inequality will be important. We have a chance to design these systems thoughtfully before things ramp up, ideally learning from our environmental and economic missteps on Earth. Underlying all these scenarios is a fundamental question. Can we expand into the galaxy ethically, sustainably, and peacefully? Or will we carry our old faults with us into the final frontier? It's both a hope and a worry. Some envision that the vastness of space and the perspective it provides could unite humanity, dissolving petty differences as we realize we're all in the same small boat, adrift in a giant cosmos. Others caution that without deliberate effort, our expansion could simply scale up our capacity for conflict. Imagine wars not just spanning countries, but planets. Perhaps the first step is cultivating a sense of stewardship rather than ownership over space. The idea of stewardship implies caring for something precious that is not solely yours. If we see ourselves not as lords of the galaxy, but as gardeners or guardians, we're more likely to approach new worlds gently. For instance, before altering a planet, perhaps we'd undertake exhaustive studies and global debates, treating the decision with the gravity of, say, deciding to dam a great river on Earth, but multiplied in significance. This could help slow down rash moves driven by profit or national pride. Ethics and empathy will also be crucial in any interaction with alien life, intelligent or not. We may need new ethical frameworks that extend concepts like rights or moral consideration beyond humans, perhaps even beyond Earth life. How do we value a totally alien life form? If it's intelligent, the answer seems clearer. We should value it as we do intelligent life here, potentially even granting it something akin to personhood in our moral and legal systems. If it's non-intelligent life, we face the same kind of questions as we do with animals and ecosystems on Earth. It has intrinsic value, but how do we weigh that against human needs? These debates, already complex at home, will gain new layers when the life in question might be unlike anything we've seen. In science fiction, authors have explored these dilemmas, providing thought experiments we can learn from. We've seen visions of benign federations, where multiple species coexist under shared principles of respect and law. We've also seen dystopias, where corporations exploit planets and authoritarian regimes rule star systems with an iron fist. While these are fictional, they spring from our understanding of human nature and history. They serve as warnings and inspirations for the path we might take. Perhaps the reality will be somewhere in between, or a mix that evolves over time. As we stand now, on the cusp of being able to reach farther than ever before, it's heartening that these conversations are happening. Scientists, ethicists, and policymakers are already discussing things like planetary protection, which is the practice of ensuring we don't contaminate other worlds with our microbes, and likewise that we don't bring back harmful organisms to Earth. That is an ethical practice rooted in caution and respect for the unknown ecosystems. Similarly, conversations about the ethics of messaging extraterrestrial intelligence, METI, weigh the potential benefits of saying hello to the cosmos against the risks, and emphasize a collective decision-making approach, should all of Earth have a say before we send a powerful broadcast to nearby stars. These are early steps toward a framework of behavior that acknowledges we have responsibilities, not just opportunities, in space. In the end, the ethos we adopt for our cosmic endeavors will shape the legacy of humanity among the stars. Will we be remembered, by ourselves, or perhaps by others, as a species that reached out with curiosity and kindness, or with arrogance and violence? It's a heavy question, but an inspiring one too. It means that our values, things like justice, compassion, and wisdom, are as vital to our space future as our rockets and telescopes. We often say that with great power comes great responsibility. The capability of faster-than-light travel, if it ever becomes reality, would be an almost unimaginably great power. It could let us scatter life, our own and perhaps Earth's other life forms, across the galaxy, or, if misused, it could lead to destruction on a cosmic scale. Ensuring responsibility keeps pace with capability will be one of the defining challenges of our species' story. As we venture forth, we will likely realize that ethical questions aren't obstacles to exploration. They're part of exploration. They force us to examine who we are and who we want to be. They encourage us to become better, so that by the time we meet another world or another intelligent species, we are fit to meet them, not just technologically, but morally. Ultimately, what kind of civilization we become in space will depend on choices made by many people over many years. Policies set by governments, guidelines agreed upon by scientists, decisions by astronauts and colonists on the frontier, and the collective voice of humanity, weighing in on what's right. This ongoing dialogue will help us forge a path that hopefully avoids the worst outcomes and moves toward the best. If we get it right, the story of humanity among the stars could be a beautiful one. A story of discovery combined with understanding, of growth tempered with respect. Perhaps future historians, or even other species, will tell tales of how the children of Earth carried the light of consciousness gently into the cosmos, lighting up new worlds without extinguishing the lights that were already shining there. The groundwork for that story is being laid even now in our attitudes and ethical principles. As we look ahead to that future, we also recognize that expanding into space will not only challenge our ethics, but transform our societies. New cultures will emerge in distant colonies, and if we do encounter alien civilizations, our own culture will expand to include perspectives beyond Earth. Humanity's identity will evolve as we incorporate the experiences of living on multiple worlds and possibly interacting with other intelligent beings. Ensuring that this cultural evolution is a rich and positive one is yet another facet of the adventure. How do we weave all these different threads, human, alien, artificial, biological, and technological, into a tapestry that benefits all? And so, as we prepare to navigate the moral landscape of interstellar life, we must also prepare to embrace the diversity that awaits. If we can manage to be just and thoughtful explorers, then the stage will be set for the next great chapter. Not just living among the stars, but living together among the stars. That means finding unity in diversity, creating common ground between Earth-born and Martian-born humans, and perhaps between humans and others who might join our circle. In short, it means weaving a fabric of society on a galactic scale. This is the challenge and promise that lies beyond mere survival and ethics. It is the prospect of a vibrant, multicultural, multi-species community spanning the stars, the very subject to which we now turn. Picture a bustling spaceport a few hundred years from now. In a grand rotating station at the edge of a star system, beings from a dozen different worlds mingle. A human trader from Mars chats with an alien diplomat from a star many light years away. Nearby, a family of explorers, freshly arrived from a warp jump, is tasting an extraterrestrial fruit for the first time, offered by a friendly vendor whose species evolved under a pale blue sun. Around them echoes a medley of languages, some spoken, some conveyed by intricate patterns of light or sound outside the range of human ears. All of it is automatically translated by devices, so no meaning is lost. This scene, once the stuff of our wildest imaginings, represents the hope that one day our galaxy could become a vibrant community of cultures, a tapestry woven from countless threads, each different, yet part of a greater whole. Long before we ever meet aliens, we will be weaving a new cultural tapestry simply by spreading out from Earth. Each new colony or settlement we form will start with the culture of its founders, but it will inevitably change and innovate in its new environment. The people who settle on a lunar base or the red sands of Mars will carry Earth's heritage with them, our languages, our art, our values. But over years and generations, they will adapt to their new home. Mars might give rise to new dialects or languages, shaped by the need to communicate in pressurized domes or by a sky with two moons. Traditions may develop around the unique aspects of living on Mars, like celebrating the beginning of spring, when the first dust storms of the season sweep across the plains, or new sports invented in the lower gravity. Meanwhile, those living in rotating space habitats, with their own engineered day-night cycles and enclosed ecosystems, will forge different customs entirely. In time, the descendants of Earth could splinter into hundreds of distinct cultures, each one tailored to its world. Despite this diversification, there will also be powerful forces knitting us back together. As long as faster-than-light travel, or at least rapid travel, is possible, people and ideas will move between these colonies. An artist from a Venusian cloud city might hold an exhibition on Earth, introducing Earthlings to Venusian-inspired styles. Students from Mars might attend university on Earth, or vice versa, carrying knowledge and perspectives back and forth. Through all these exchanges, a shared sense of being human may persist, even as the definition of human culture broadens. In effect, humanity could become not one monoculture, but a family of cultures, a bit like the rich patchwork of nations and peoples on Earth, but multiplied across planets. Now imagine adding other intelligent species into the mix. The day we establish contact with an alien civilization will be a turning point, not just scientifically, but culturally. Suddenly, we won't just be comparing notes between different branches of humanity. We'll be encountering minds that evolved on entirely different terms. Their art might be in forms we hardly recognize. Perhaps music made of gravitational wave harmonics, or visual art drawn in magnetic fields. Their social norms might at first seem bewildering. What an opportunity that will be for learning. Just as the exchange of ideas between East and West on Earth in past centuries sparked new philosophies, and the blending of different musical traditions gave birth to new genres, interacting with alien cultures could ignite creative renaissances we can scarcely imagine. We might collaborate with aliens to create fusion art forms, say, a performance that combines human storytelling with alien telepathic imagery, creating something neither could produce alone. Of course, cultural exchange requires patience and open-mindedness. There will inevitably be misunderstandings. We might inadvertently offend an alien guest by doing something that seems harmless to us, but is taboo to them, or vice versa. We have some experience with this, as even within our own species, cultural differences can lead to accidental slights and conflicts. The key is establishing mutual respect and a willingness to apologize, forgive, and educate. Over time, we would likely develop a set of interstellar etiquette, guidelines for polite interaction across species, perhaps overseen by a representative council, where each culture contributes its perspective. Think of it as an extension of what we try to do globally now, in forums like the United Nations, but on an even broader, more diverse scale. Language, often a barrier on Earth, might be less of one in the future with technology. Even today, we have early versions of universal translator devices for human languages. By the time we meet aliens, our translation tech might be sophisticated enough to handle completely new languages, enabling real-time conversation. Yet translation is more than words. It's culture, context, idiom. We will have to learn not just vocabulary, but worldviews. Some concepts fundamental to humans, like our idea of family or ownership, might not have direct equivalents in an alien society, and they will have concepts that challenge us in return. This learning process will be one of the great adventures of the future, truly seeing the universe through others' eyes. When cultures weave together, new patterns emerge. On Earth, globalization has led to wonderful syntheses. Cuisine is a simple example, where ingredients and techniques from different corners of the world combine to create new flavors. In a galactic civilization, imagine the cuisines that could emerge when chefs have an entire universe of ingredients. Spices from Earth, fruits from an alien jungle, grains grown on a space station. Imagine literature co-written by human and alien authors, blending storytelling traditions, or medical knowledge shared across species, so that each benefits from the other's insights into biology and healing. Even spiritual life might transform. Perhaps one day, humans and aliens will attend interfaith gatherings, discovering that a hymn sung by a creature from another world moves them, or that an alien philosophy about the stars complements an ancient human wisdom tradition. Yet, there is also the risk of cultural homogenization, the possibility that one dominant culture could steamroll the rest. We see hints of this today. Smaller languages and traditions sometimes fade under the influence of more dominant ones, spread by mass media and economic power. In a future galactic society, particularly if humanity is first on the scene, or if one species is particularly influential, there could be a tendency for weaker or smaller cultures to be subsumed. Guarding against that requires conscious effort. It means creating space for each culture to celebrate itself and be appreciated by others. Perhaps galactic holidays will be established that rotate focus on different civilizations' important celebrations, so everyone gets to share in them. For instance, humans might invite others to experience a reenactment of the first moon landing as a historical celebration, while an alien species might invite us to commemorate an event of equal significance in their history. Through mutual celebration, understanding deepens. We might also see the development of entirely new cultural identities that are not rooted in a single species or planet, but in an ideal or community that spans many. Consider something like a galactic university, where members of various species live and study together for years. Those graduates might feel a strong bond with each other that transcends their origins, having formed a microculture of their own in the halls of learning. Or multi-species crews of starships, who, facing challenges side by side, develop their own tight-knit culture, blending customs and catchphrases from everyone on board. These microcosms could be seeds for a larger shared identity, not replacing individual heritages, but layering on top of them. A person, or being, in the future might proudly say, "I am from Earth, and I'm also a citizen of the Galactic Federation," just as someone today might say they're proudly Irish, and also proudly European, or proudly Japanese, and also part of a global scientific community. Every thread in the tapestry adds strength, but weaving them isn't always easy. Conflicts might still arise. Perhaps two species have historical grievances, or fundamentally different values on a certain topic. Diplomacy and empathy will be our tools to address such issues. Here, humanity's own diversity can be an asset. We have many perspectives within us, so we might be especially suited to finding common ground. If we've learned to resolve differences among ourselves by then, a hopeful assumption, those skills will apply externally as well. It's also possible that in the far future, our differences with aliens could diminish in importance as we face challenges collectively. Just as nations on Earth often set aside differences to deal with global issues like climate change, multiple species might unite to address cosmic-scale problems, anything from a dangerous asteroid on a collision course to the long-term question of how to survive as our sun ages. Working together on such projects can create a sense of unity. Nothing bonds disparate groups like working toward a common goal, especially if that goal is existential. In many science fiction stories, humanity only truly unites when faced with an external threat or mystery. Similarly, the arrival of other intelligent species could be the catalyst that finally makes human unity more than a dream, and in turn, the collaboration between species on grand projects might forge a unity at an even higher level. Weaving cultures together does not mean making them all the same. In fact, it means the opposite. In a weaving, threads retain their individual colours, and it's the contrast and interplay that form a beautiful pattern. In a thriving galactic society, a traveller should be able to go from planet to planet and marvel at how different each one is, delighting in the distinct music, architecture, fashions, and philosophies, while also feeling that they all share a commitment to certain core principles, like respect for life and intelligence, and perhaps a gentle sense of humour about the quirks of each other's ways. Imagine participating in a festival on a distant world. You might not fully understand the symbolism at first, but local hosts guide you, just as we guide visitors at our cultural festivals on Earth. And by the end of the night, you're dancing under unfamiliar stars, part of a story that began light years away. Those kinds of moments will make the galaxy feel wonderfully intimate, despite its physical vastness. Technology will play a part in facilitating this cultural tapestry. the same way the internet has connected far-flung communities of people with niche interests across Earth. A future interstellar communication network, whatever form it takes, could allow, say, a human poet on a colony around Alpha Centauri to collaborate in real time with a chorale of singers from 3 different species in a distant cluster, creating art that combines their talents. Virtual reality, or its future equivalents, might let individuals from different planets feel like they are in the same room, bridging light years for a conversation or shared experience. Perhaps there will be galactic museums, accessible through immersive tech, where one can tour the cultural treasures of numerous civilizations in a single afternoon. Today, an earthly museum might have Egyptian and Chinese artifacts side by side. Tomorrow's might have artifacts from multiple worlds, curated respectfully with context provided by members of those cultures themselves. The ultimate success of this grand weaving will likely lie in our ability to balance unity and diversity. Too much insistence on unity can tip into uniformity and oppression of difference. Too much emphasis on diversity without unity can lead to fragmentation and misunderstanding. The image of a fabric is apt. If the threads don't hold together, you have no cloth. If they lose all their distinct colors, the pattern is lost. We will have to create shared institutions like councils, festivals, marketplaces, educational systems that encourage interaction and mutual appreciation without enforcing any single cultural norm on everyone. Will it be perfect? Certainly not. Human history shows that blending cultures can be messy and fraught. There are missteps, backlashes, periods of tension. Likely, our interstellar future will see its share of cultural growing pains. But we can hope that the stakes and wonders of that era will inspire the better angels of our nature. After all, if you can travel faster than light and behold the grandeur of the cosmos firsthand, perhaps pettiness and prejudice start to seem trivial by comparison. Perhaps encountering the true alien will make the differences among humans, or among any one species, feel much smaller and more surmountable. In the face of the cosmic unknown, we might all become a bit more humble and a bit more curious, which is a good recipe for getting along. At this moment, all of this remains an imaginative exercise. We have yet to break light speed. We have yet to meet anyone else in the universe. But already, in our minds and through our stories, we are preparing for it. We imagine these scenarios not just for entertainment, but as a form of rehearsal for a future we dearly hope will come. Each science fiction novel or film that shows species dining together, each make-believe universal translator or interstellar alliance, is priming us to believe that such harmony is achievable. And when we return from these flights of fancy to the present, we find that even now, the spirit of that future is alive in small ways. Consider the International Space Station orbiting above us. Multiple nations came together to build and operate it, and on board, astronauts from different countries live and work side by side, sharing meals, traditions, and languages. It's not alien life, but it is a microcosm of international culture beyond Earth. Or consider how global the scientific community is, uniting people of myriad backgrounds in pursuit of knowledge about the stars. These are threads of unity that we can continue to spin outwards. The warp and weft of space, this idea of crossing the void and creating something meaningful there, ultimately comes down to people, human or otherwise, connecting with people. Faster than light technology, if it ever arrives, will be the physical warp drive that moves our bodies across the galaxy. But equally important is the metaphorical warp drive that moves our hearts and minds, the drive to connect, to empathize, to learn, and to create together. With both in hand, the universe could truly become a home, rich with friendships and discoveries beyond counting. As we conclude this part of our journey, we're left with a vision of the cosmos, alive with conversation and color. A great weaving of civilizations, each contributing its pattern to the grand design. It's an inspiring picture, one that calls on us to be both brave explorers and conscientious weavers of community. How close are we to that reality? And what steps are being taken today to move us toward the stars? Those questions carry us onward. For now, we live on one little planet, looking up and dreaming of light-speed voyages. But every story we've told, every theory we've devised, every rover we've sent to a neighboring world is a thread in the loom, preparing us for the day we'll add our own chapter to the cosmic tapestry. The story of faster-than-light travel is, in a sense, the story of our yearning to belong to something larger, to break out of our solitary cradle and join the universe at large. That story is still unfolding. With each passing year, science brings new insights, and imagination brings new dreams. One day, perhaps sooner than we dare think, the barrier of light might be crossed, not just in fiction, but in fact. And on that day, all the themes we've explored, our scientific ingenuity, our caution and wonder, our ethics and our hopes for community, will come together as we take our first true step into a broader cosmos. In the tapestry of time, that will be the moment when humanity begins weaving itself indelibly into the fabric of the galaxy. Until then, we continue to imagine and to prepare, our eyes on the stars and our hearts full of longing for the day we finally soar among them. For generations, we had only been able to imagine this moment. Faster-than-light travel lived solely in our dreams, in the pages of old science fiction novels, in the equations scribbled by hopeful physicists, in midnight conversations, gazing up at the stars. Now, at long last, it is here. Under the silent twilight sky, a sleek starship waits, like a glimmering arrow pointed toward the unknown. All the hopes and longings of our species seem to tremble in the air around it. It is as if the earth itself holds its breath, watching with a mix of excitement and wonder. After centuries of yearning and decades of preparation, humanity stands at the threshold of interstellar flight. On this day, an entire planet turns its eyes upward. In the hush before dawn, the launch site shimmers with floodlights and starlight. A low countdown voice from mission control steadily marks the final seconds, each number reverberating in hearts around the world. The air is electric and still. At the moment of zero, engines ignite with a blinding flare and a thunderous roar. A deep rumble rolls across the distance as the starship rises above the pad, defying gravity's ancient pull. Slowly at first, then with gathering speed, it ascends through thin bands of cloud, leaving behind the only home humanity has ever known. Far below, spectators gasp and cheer, many with tears of joy, as their eyes follow the bright trail climbing into the sky. Across continents, millions watch the live broadcast in collective wonder, sharing in this singular moment of hope. In a quiet village, halfway around the world, a young child stands on a rooftop with her grandmother, eyes glued to a tiny speck of light rising in the pre-dawn sky. They watch as the brilliant plume of the starship fades into the heavens. The grandmother whispers that in that ship, humans are truly going to the stars. The child's heart swells with wonder. In that moment, on that humble rooftop, another dream is born. One day, she too might journey beyond Earth, following the path of that glittering vessel into the great unknown. Inside the cockpit, instruments glow softly, and the hull vibrates as the atmosphere thins. The crew remains focused and calm amid the mighty forces at work. Each astronaut is strapped snugly into their seat, having trained for years for this moment. They exchange quiet, determined smiles as blue sky outside their window deepens to velvety black. Acceleration presses them back, and they feel the tremble of power beneath their feet. Through their visors, they watch the curve of Earth falling away below and the stars emerging above. Nothing could truly prepare them for this sight, the boundary between Earth and space slipping past. In their hearts, they carry the hopes of billions, aware that all of humanity is riding with them in spirit. Radio voices crackle in their ears as flight controllers confirm a successful ascent. The first leg of their journey, lifting off from Earth, is complete. Gliding free of Earth's embrace, the ship now coasts in orbit. The world they left behind is a glowing blue crescent, slowly receding. For a moment, the crew floats in weightlessness, unstrapping and peering back at their home, shining against the black of space. But ahead lies only night and endless stars, and the true journey is just beginning. Far from any city lights or atmosphere, the stars gleam in unfiltered clarity around them. At a safe distance from home, they prepare to engage the faster-than-light engine at last. Final system checks echo through the cabin. This engine, a revolutionary warp drive that will bend the fabric of spacetime, has been tested only in theory and unmanned flights. Now human travelers will trust it with their lives and hopes. There is a hush on board as the decisive moment arrives. Time seems to hold its breath. The captain's voice is calm as they give the go signal. Fingers hover over controls. Hearts thud in chests with anticipation. A deep vibration starts to build from the core of the vessel, resonating up through the floor. Space itself appears to ripple around the ship. Suddenly, a brilliant wave of energy surges outward, and the pinpoints of starlight ahead stretch into shimmering lines. In a heartbeat, the starship vaults forward into the unknown, breaking the barrier that held us bound to the sun's domain. Inside the ship, the crew feels a mild surge as they cross the threshold of light speed. Then comes an uncanny stillness. The view outside stabilizes into a surreal tunnel of starlight as the craft races onward. For a moment, no one speaks. They are awash in the miracle of the moment. Then the instruments confirm it. They are traveling faster than light. A collective exhale of relief and triumph fills the cabin. Some laugh. Others find tears in their eyes. Back on Earth, in mission control, engineers and onlookers erupt in celebration as telemetry signals that the ship has successfully made the jump. Across the planet, people shout and weep with joy. Humanity has broken a barrier as fundamental as dawn. For the first time, a crewed vessel is streaking between the stars at superluminal speed. The sun and Earth swiftly shrink into memory behind them. Ahead, the distant lights of other suns beckon, no longer unreachable. The vast emptiness between worlds, once an impassable gulf, begins to yield to our bold steps through space-time. Their course is set toward a faint, ruddy star that humans have long seen only as a distant glimmer. Proxima Centauri, the nearest neighbor to our sun. Even at faster-than-light velocity, the journey will take some time, but a mere fraction of what once seemed impossible. As hours turn to days on board, the crew adjusts to a new routine of life in transit between stars. They share meals, record their observations, and gaze out windows at sights no human has witnessed before. In the first minutes of their leap, they passed beyond the farthest extents of any previous spacecraft. The Voyager probes and New Horizons, once the lonely heralds at the solar frontier, were left far behind in an instant. Now they traverse an expanse that for eons separated us from even our closest stellar neighbour. Out of the window, familiar constellations begin to warp and skew. Orion's once familiar belt and the Dipper's shape distort gradually as their perspective shifts light years from home. One evening, a crew member pauses at a viewport to look back. In the distance, the sun is just a faint pinprick of light among countless others, indistinguishable to any uninformed eye. It strikes them how small and precious that spark is. All of human history emanating from a tiny glow now nearly lost in the darkness. Yet their hearts swell with pride and wonder. That little star is proof of how far they've come. Meanwhile, ahead in the forward view, a new star grows slowly brighter. Proxima Centauri, once just an entry on star charts, is becoming a sun with real warmth and light, awaiting their arrival. As they voyage on, the interstellar void reveals its subtle beauty. At times, the crew dims the cabin lights to press their faces against the viewport, watching stray particles of cosmic dust ignite into brief streaks of light as they brush the ship's energy field. Occasionally, they pass the ghostly glow of a distant nebula, or catch the faint twinkle of a comet far off their trajectory, reminders that even the emptiest stretches of space hold wonders. In quiet moments, someone will play a soft tune on a portable keyboard or hum an old lullaby, the gentle notes drifting through the cabin, a human comfort carried into the depths of space. During these long hours, friendships aboard deepen. Crew members share stories of what drew them to this mission. Childhood nights spent stargazing, the inspiration of science fiction tales, a simple desire to give future generations the gift of the stars. In the peaceful stillness between destinations, they come to realize that the journey itself is changing them, bonding them not only as a team, but as a family among the stars. At last, after a journey of immense distance, compressed into mere days, their new sun comes into clear view. Proxima Centauri, a cool red star, casts a gentle glow through the cockpit windows. Around that alien sun circles a planet once known only by a catalogue number and a few tantalizing data points. Now it is directly below them, very real and beckoning. The world has swirls of white cloud and patches of deep green and blue, hinting at oceans and perhaps life-cloaked continents. The crew brings the starship into orbit, floating above an unknown landscape. They exchange astonished glances. Everything their ancestors had only imagined is now tangible beneath their feet, separated only by the hull of their ship. Sensors sweep the surface and atmosphere, confirming an environment that, while exotic, might support human life with some precautions. Their excitement is tempered with caution and respect for this untouched place. Soon, a smaller landing craft detaches from the main ship and begins its descent towards the planet's surface. Through wisps of cloud, they glimpse alien terrain rising up to meet them. Dark mountain ridges and gleaming lakes under a dimmer, rust-coloured daylight. The craft touches down on a flat, rocky plain covered in strange, mossy growths. When the engines wind down, a profound quiet surrounds them, broken only by the soft hiss of the wind. Donning their protective suits, the explorers step out one by one onto the strange soil. The first boot presses into reddish dust and leaves an imprint. At that instant, humanity has set foot on a planet beyond our solar system. One explorer bends down and gathers a small scoop of soil in a gloved hand, letting it trickle slowly back. Even through the visor, tears are visible in their eyes. Above them, the sky has a faint copper hue. The star Proxima hangs low, a red disk giving off a gentle light. For a moment, they all stand silently on this new world, absorbing the reality. In that silence is the culmination of centuries of longing, a quiet triumph that echoes from this alien plane all the way back to their home planet, now a distant star in the sky. In the days following that first landing, the handful of explorers transforms from visitors into settlers. They establish a small encampment at the landing site, deploying inflatable habitats and solar collectors on the alien soil. Every task is a first. The first meal prepared on another planet. The first night's sleep under an alien sky. The first time humans build a shelter beyond Earth. There is a sense of profound responsibility and care guiding each step. They know they are not just explorers now. They are the founders of humanity's first outpost among the stars. At night, the crew gathers outside their habitat in their suits, gazing up at unfamiliar constellations. Somewhere up there, a tiny star is the sun, where their friends and family watch and wait for news. On that first strange night, they lie awake for a while, noting the unfamiliar silence. No chorus of earthly insects or hum of distant cars, only the whisper of an alien breeze against their habitat walls, reminding them how far from home they truly are. The radio signals and data sent back to Earth spark a wave of celebration and determination. Humanity learns that a new world truly awaits among the stars, and it is hospitable enough to dream of living there. Almost immediately, efforts begin to send more people and supplies. What was once a far-off aspiration turns into concrete plans. Workshops and spaceports on Earth and Luna go into overdrive, constructing the next generation of starships. Larger vessels designed not just for exploration, but for migration. Volunteers from every corner of the globe step forward, eager to be part of this grand journey. Scientists and engineers, farmers and doctors, builders, teachers, and artists all prepare for a life on a distant planet. Entire families plan to embark, willing to trade the familiar comfort of Earth for the promise of a new beginning beneath alien skies. In a rare moment of unity, nations set aside differences and pool resources to support the first interstellar colony. This venture is seen not as belonging to one country or group, but to all of humanity. The colony on Proxima's planet is christened with a name symbolizing hope, a name that in many Earth languages means dawn or new Earth. Its story is shared in every school and home, inspiring a generation that will follow in the footsteps of these pioneers. Months turn into years. The little temporary camp grows steadily into a true settlement. One day, the original explorers look up to see a gleaming new ship descending through the thin clouds, bringing the first wave of settlers from Earth. There are joyous embraces as new boots step onto alien ground and fresh voices fill the air. For the original pioneers, who had lived with only each other's company for so long, seeing those new faces and hearing new voices is overwhelming and joyous. Proof that their once lonely outpost is truly becoming a community. They expand outward, constructing sturdy dwellings from prefabricated materials and local stone. They raise domed greenhouses where seedlings from Earth are coaxed to grow under the strange daylight. Rows of familiar green shoots sprout in alien soil, slowly adapting to the red-tinged sun. Engineers set up systems to tap into the planet's resources, filtering water from underground springs, generating power from steady winds that sweep the plains at dusk. Each evening, the settlers gather in a central common hall they built together, sharing stories of their day's labor and marveling at how quickly life has taken root here. In that hall, under hanging lights, and with the gentle hum of generators in the background, new traditions begin to form. One quiet night, a colonist produces a well-traveled guitar that had been carried from Earth and begins to strum a familiar folk song. Others gradually join in, humming and singing softly, their voices mingling beneath the alien sky. In that moment, the little group feels a comforting sense of home, thousands of miles away from Earth, yet present right here in their shared warmth and music. There are challenges, of course. At times, unexpected dust storms blow in from the alien deserts, testing the strength of their structures. The settlers take such trials in stride. When a fierce gale once tore loose part of a habitat cover, the whole community worked through the night in swirling red dust to secure it, emerging exhausted but triumphant with a stronger shelter design. Some earth plants struggle in the foreign soil or under the dimmer sunlight, forcing the colonists to innovate with new farming techniques and hardier crops. But each obstacle is met with creativity and determination. Bit by bit, life on this distant planet becomes not only possible, but comfortable. Then comes a truly historic moment that underscores how established the settlement has become. The birth of the first child on this world. In a small medical bay, a newborn's cry rings out. The first sounds of a human life that has never known Earth. The colonists rejoice. Some weep tears of happiness and relief. They cradle the infant under the soft glow of artificial lights, knowing that this little one is the start of a new generation, a generation for whom this alien world will be home. When news of the birth reaches Earth, sent over a faster-than-light comlink developed soon after the first voyage, humanity celebrates this symbol of the future. On the colony, the parents step outside with their baby swaddled safely and gently lift the child toward the alien sun, its rays bathing them in a gentle copper light. It is a quiet, heartfelt gesture, a welcome from the entire planet to its newest resident. Buoyed by the success of the Proxima colony, humanity's reach continues to extend outward. Before long, new missions depart for other beckoning lights in the night. Alpha Centauri's twin stars, long the subject of speculation, gain their own outpost on a planet where two suns dance in the sky, granting twin dawns and twin sunsets each day. A little farther out, an expedition reaches the dim orange glow of Barnard's star and founds a research base on a frozen world, its people adapting to long, cold nights and ruddy daylight. In the Tau Ceti system, colonists touch down on a planet with gentle blue oceans and arching ringed bands in its sky. There they build homes along alien shorelines, watching multiple moons rise together on quiet evenings. Even the distant TRAPPIST-1 system, with its family of 7 Earth-sized worlds locked in a cosmic dance, eventually receives a human presence. On one of those tightly orbiting worlds, settlers live under perpetual twilight, farming beneath the faint illumination of a red dwarf sun that never fully sets nor rises. Each new world brought its own wonders and trials. On some, the air was thin and crisp, requiring habitats pressurized like high mountaintops on Earth. On others, gravity was lighter, and children joyously leapt higher than any human could on Earth, turning low-gravity somersaults under unfamiliar constellations. There were planets with skies that glowed green at sunrise due to chemical-rich atmospheres, and worlds where alien flora painted entire valleys in colors never seen before by human eyes. On one lush planet, the settlers glimpsed small, fluttering creatures darting among the exotic foliage, the first animals native to an alien world that humans had ever encountered. They observed in reverent awe, careful not to disturb these delicate life forms, mindful that they were guests in these ancient ecosystems. The settlers, on a desert exoplanet, learned to build dwellings deep underground to escape searing daytime heat. Those on a water world floated in cities of interconnected ships and platforms, drawing sustenance from strange marine life beneath them. At every new colony, humanity proved both its resilience and its reverence, adapting to harsh conditions with technology and ingenuity, while also vowing to protect any native ecosystems they encountered. Bit by bit, what started as a single foothold at Proxima grew into a scattering of human lights across the nearby stars. Maps of the night sky, once drawn with all arrows pointing inward toward Earth, are now being redrawn with multiple centers. With each passing generation, the colonies mature and develop their own identities. Children grow up knowing the alien sky above as their sky, the strange constellations and twin moons as their normal night. Unique customs and cultures emerge, festivals timed to the rhythms of two suns, art inspired by alien landscapes, new languages and accents blending settlers' origins with their new environments. Yet despite their growing independence and diversity, all these distant human outposts stay connected by the threads of their shared origin. They remain proud of being pioneers, carrying the spirit of Earth to the stars. People on different worlds communicate, exchange knowledge, and offer aid in times of need, ensuring that even light years apart, humanity remains one family. For instance, when a severe drought once threatened the food supply of one fledgling settlement, others pooled their surplus harvests and dispatched a fast supply ship across light years to lend support, preventing hardship and strengthening the bond between these far-flung communities. And always, underlying the excitement of colonization, is a persistent, profound question that has echoed through history. Are we alone in the universe? Now that we walk on multiple worlds and sail routinely across light years, this question feels more pressing than ever. In the quiet nights on these new planets, settlers sometimes look up and wonder if somewhere out there in the dark, other beings are gazing back. Humanity has reached across space and found new homes, but so far, we have found only ourselves. Still, our scientists and dreamers do not stop listening. Powerful radio dishes on distant colony hillsides turn their ears to the sky, and observatories on moons and asteroids scan for any faint whisper of intelligence. We feel in our bones that somewhere out there, someone else might be looking our way too. But the silence in the stars will not last forever. It happened quietly at first. Late one evening on a frontier colony, an astronomer was monitoring the heavens as they often did, scanning for anything unusual in the radio waves from space. For years, these scans had found nothing beyond the natural whisper of pulsars and the faint static of distant stars. But on this night, something different emerged from the noise. A signal, regular and pulsing, with a pattern that nature alone could not create. The astronomer nearly stopped breathing as they watched the telemetry draw out a series of unmistakably structured bursts. There was an intelligence behind it. The astronomer immediately double-checked every instrument, ensuring this was no glitch or stray interference. When the pattern persisted, she alerted fellow scientists, her voice shaking with excitement. Soon, observatories across Earth and the colonies swiveled their dishes to the source and confirmed it. The signal was real. Word spread swiftly through scientific circles and then to the public. We had detected a message from somewhere out in the darkness. Humanity collectively leaned forward, heart pounding, at this cosmic whisper from the unknown. The signal was faint, coming from a star system many light years beyond even the furthest human colony, but it was clear and repeating. The mysterious transmission was analysed feverishly. Its pattern suggested intelligence. Some believed it was a sequence of prime numbers. Others noted a cadence like a simple musical melody across the radio spectrum. No direct language could be discerned, but the very regularity of it felt like a friendly wave across the cosmic gulf. Debates sparked across all the worlds of humankind. Many cautioned prudence. The idea of contacting an unknown species stirred both hope and anxiety. Could we be risking danger, or reaching out to friends? Ultimately, curiosity and optimism won out. How should we reply? What should we say? What if, instead of replying with radio, we visited them directly? Our fastest ships could bridge that distance far quicker than the decades or centuries radio signals would take. Before long, a bold plan took shape. An ambassador mission would journey to the source of the signal. Unlike previous expeditions, this voyage was not about finding a new home or resources. It was about meeting neighbours. A special delegation was assembled, comprising scientists, linguists, diplomats, and explorers, all entrusted with representing humanity. They prepared carefully, loading their vessel with offerings meant to convey friendship. Golden discs etched with images of Earth's people and animals, recordings of music from Bach to folk songs, spoken greetings in dozens of Earth's languages, artworks and mathematical charts, a cosmic greeting card from Earth. There was both excitement and trepidation. As the ambassador ship finally launched into the starry void, billions watched and hoped. The crew themselves felt the enormity of the moment. They were carrying the voice of an entire civilization with them into the unknown. During the voyage, the crew alternated between rigorous preparations and moments of quiet reflection. They knew they were speeding toward a moment that would redefine history, and each spent time gazing out at the stars ahead, wondering what the beings on the other end of the signal would be like. After a long, faster-than-light journey, the ambassador ship reached the outskirts of the distant star system from which the signal originated. Excitement and nerves ran high as they soon discovered they were not alone. Instruments had already picked up faint artificial signals and even orbiting satellites around the target world. Undeniable evidence of a civilization at work. All eyes pressed to the viewing ports or screens as they approached. A sleek, silvery shape glided through the void toward them. It was graceful, almost organic in design, like a manta ray swimming in an endless night. Soft lights glittered along its hull. A hush fell over the crew. This was it, the first meeting. The alien ship halted at a safe distance, and for a few long minutes, both vessels simply floated in the starry silence, studying one another across the void. Then a transmission came through, not as the random signal from before, but directed at us. It was a series of tones and flashes of light, deliberate and rhythmic. Our crew responded in kind, using simple patterns of light from our ship's lamps and basic mathematical radio pulses, a mutual sign of peaceful intent. Slowly, trust grew that neither side meant harm. After some cautious back and forth, an agreement was reached to meet face to face on neutral ground. A small, cratered moon nearby was chosen as the rendezvous point. Under the pale light of a distant sun, the human landing craft set down on one side of the barren moon, while the alien shuttle alighted on the other. The surface was airless and silent. Both parties would have to meet in their respective suits. A handful of representatives from each side stepped out onto the dusty grey regolith, hearts pounding with anticipation. From the human side walked the captain, a scientist, and a translator, carrying devices to bridge the communication gap. From the alien side came figures a little taller and slenderer than humans. Through the translucent panels of their suits, one could glimpse forms that were truly alien, yet eerily graceful. Skin with a faint shimmer under the starlight, large luminous eyes adapted to a different sun. They walked on two legs, but their gait was fluid and light in the low gravity. Both groups approached each other slowly across the open plain. The only sound in the human explorers' ears was their own breathing, loud in the helmet, and the soft crunch of their boots on the moon dust. When they were just a few paces apart, both stopped. A human unhooked a tether on their suit and raised an open hand in greeting. One of the aliens mirrored the gesture, raising their delicate three-fingered hand, palm outward. In that simple motion, across an unimaginable gulf of evolution and culture, both understood. This was a greeting, a gesture of goodwill. In a carefully choreographed move, the human ambassador produced a small object they had brought, a globe of Earth encased in transparent material, and held it out. An alien stepped forward and gently accepted this gift, cradling it for a moment before giving a subtle nod. In return, the alien reached into a pouch and revealed their own token, a smooth disc of metal engraved with unfamiliar yet beautiful symbols. They offered it to the humans. Our leader accepted it with a slight bow. Though no words were yet exchanged, these acts spoke volumes. Both sides were saying, "We come in peace, we seek friendship." Soon, through a combination of gestures, drawings on tablet screens, and translation software working overtime, a primitive dialogue began. What an overwhelming moment it was. Each side hearing the voice of another intelligent species for the very first time. To human ears, the aliens' voices sounded musical and soft, unlike any language on Earth. To the aliens, our voices were equally novel. Yet, piece by piece, a bridge of understanding started to form. They learned that these beings had picked up the flares of our warp drives and our early broadcasts, and had been eager to know who we were. Just as we had long wondered about others, they too had gazed at the cosmos in search of friends. And now, here we stood together, two civilizations meeting for the first time, not as enemies, but as fellow travelers in the great darkness, both filled with relief and wonder at not being alone. When news of the successful encounter reached human worlds, a wave of amazement and celebration swept over our species. Images of humans and aliens standing together on that rocky moon were broadcast to every colony and back on Earth, inspiring awe. In capital cities, crowds danced spontaneously in the streets beneath big screens, replaying the historic handshake on that distant moon. In small towns and remote villages, families stayed up late, pointing at the night sky in disbelief and gratitude. Old rivalries on Earth were forgotten, at least for that night, as humanity experienced a collective moment of unity and joy unlike any before. People gathered in city squares and remote outposts alike to rejoice in this profound milestone. We had answered the age-old question, and the answer brought tears of joy. There were others out there, and they welcomed us. On the alien side, we later learned, their own communities experienced a similar swell of hope and excitement, to discover they were no longer alone. The universe, once silent, now echoed with new voices greeting each other. This first contact was only the beginning. In the months and years that followed, formal relations were established. We exchanged knowledge, stories, and dreams with our new acquaintances. Small delegations from each planet soon crossed the void again to pay formal visits. Human envoys, carefully suited for an alien atmosphere, set foot on the visitor's homeworld and were welcomed in ceremonies beneath unfamiliar stars. Likewise, alien ambassadors travelled to Earth, gazing in wonder at our blue skies and vast oceans, and to human colonies, where they shared meals and laughter with people who, months before, had been strangers from another sun. They hinted at others out in the great darkness, distant civilizations they had only glimpsed in faint signals, much as we once had. Humanity was now part of a much larger community of life, a single thread woven into a cosmic tapestry of many colours. The stage was set for a galactic era of exchange, of trade, communication, and connection that would intertwine numerous worlds and cultures. A new era unfolded in the wake of first contact. The great void between stars, once silent and desolate, is now alive with activity. If one could stand back and observe the galaxy at this time, they would see the faint glimmering threads of countless journeys, starships streaking from world to world, weaving connections where none existed before. What had been isolated islands of life are becoming an archipelago linked by currents of trade, communication, and cooperation. Each faster than light jump, each message sent across the darkness, is like a shuttle weaving the warp and weft of a galactic tapestry, binding together species and civilizations. Trade flourished. Fleets of transport ships carried goods and resources that once would have been beyond price. Grain harvested under the light of a red dwarf sun was baked into bread on Earth, carrying a subtle new taste that Earthlings delighted in. Meanwhile, earthly treats like rich chocolate and coffee made their way to distant planets, where alien beings savoured these flavours with fascination. Markets sprang up on colony worlds, selling fabrics woven from alien plant fibres, and in turn, exporting sturdy textiles from Earth's cotton and flax. Precious minerals unique to one world were traded for advanced medicines developed on another. One species' waste byproduct became another's invaluable fuel, creating symbiotic economies that linked planets in mutually beneficial exchange. Starships laden with cargo became a common sight streaking across the stars, connecting the ecosystems and industries of many worlds. Alongside the flow of goods was a rapid exchange of knowledge and information. Human scientists collaborated with alien researchers to unlock new scientific breakthroughs, developing cures for diseases once thought incurable, and helping restore environments on both Earth and other worlds. Breakthroughs and news that once took years to spread now traversed the settled worlds in a flash, thanks to a growing network of communications relays spanning the stars. Quantum entanglement communicators and subspace links, innovations born from combined human and alien ingenuity, allowed messages to leap across light years almost instantaneously. A doctor on one planet could consult with colleagues on another about a medical mystery in real time. A family separated by 10 light years could exchange morning greetings as easily as a video call across town. This interstellar web of communication wove everyone closer together, making the galaxy feel smaller and more intimate. As travel became routine, so did personal voyages between worlds. Students from Earth went to study at universities on distant planets, while alien scholars came to learn at human institutions. Tourists with a sense of adventure could book passage on luxurious starliners to visit the crystalline beaches of an exoplanet ocean, or the shimmering cloud forests of a far-off moon. Entire industries emerged around hosting visitors eager to experience the wonders of worlds they had only heard about. On one planet, a human might stand under the sky of twin suns, awed by a double sunset, while on another, an alien might gaze in wonder at the rain in an earthly rainforest brought to a colony's biodome. These shared experiences broadened minds and fostered empathy between species, as each could directly appreciate the beauty of the other's homelands. Adventurous crews soon became mixed, with humans and aliens serving side by side on the same starships. On exploration missions to uncharted regions, these diverse teams forged deep friendships as they charted new frontiers together, their unity a testament to how far trust had come. In hubs across the galaxy, true cultural melting pots formed. Space stations at strategic crossroads became bustling bazaars and meeting places for countless beings. In the promenades of these grand stations, humans walked side by side with tall, graceful aliens and other strange and friendly creatures from systems even further away. Stalls in the marketplace offered fruits from 3 different planets, artwork crafted by appendages unlike our own, and music that blended instruments and styles from multiple worlds. A traveller passing through might hear a melody played collaboratively by human and alien musicians, the harmonies enriched by their diverse backgrounds. At a cafe overlooking the docking bays, one could see children of different species playing together, teaching each other games from their respective cultures, laughing without any barrier between them. Among them, a human child sits beside an alien youngster, each teaching the other words from their native languages. They point and laugh, finding delight in their differences with a natural ease. To these children, born into an age of interstellar camaraderie, being friends with someone from another species feels perfectly ordinary. From time to time, the galactic community comes together in grand celebration, on a vast, rotating space habitat serving as a neutral gathering place. Beings from dozens of worlds convene under an artificial sky painted with constellations from every sector. They share music and dance, each species contributing its most cherished traditions. Alien melodies intertwine with human songs, and delicacies from countless planets are passed around freely. In these festivals of light and life, everyone feels the profound unity of a tapestry woven from many threads, a living mosaic of cultures shining together in friendship. To guide this burgeoning community, informal councils begin to form. Leaders and ambassadors from various worlds convene periodically, at first in ad hoc meetings on neutral ground, and later as part of a more established galactic assembly. They discuss matters of shared interest, navigation routes, joint scientific endeavours, the preservation of peace and justice among worlds. They also embark on ambitious joint initiatives, mapping the spiral arms of the galaxy, establishing interstellar research stations, and safeguarding planets from cosmic dangers such as asteroids. Language barriers gradually fall as dedicated translators and new lingua franca allow disparate species to communicate in assembly halls filled with many voices. There are inevitable misunderstandings and challenges. Once, a disagreement over trade sparked tension between 2 worlds, but through open dialogue at the Galactic Council, it was peacefully resolved. Time and again, empathy prevails over strife. From these meetings emerge agreements and alliances, a framework ensuring that trade remains fair, that knowledge is shared ethically, and that no world will dominate or harm another. In essence, we are learning how to live not just as one people on one planet, but as many peoples on many planets, bound by a common dream of prosperity and understanding. Standing in this new age of interstellar civilization, one cannot help but look back at how far we've come. Faster than light travel, once a wild fantasy, has utterly transformed the human story and the stories of those we've met. We have gone from stargazers to starfarers, from dreaming about other worlds to building our lives upon them. The legacy of those first brave steps into the cosmos is all around us. In every friendship between species, in every child born under an alien sky, in every sunrise witnessed on a world once unknown. It's worth remembering how far we had to climb to reach this threshold. Only a few centuries ago, humans had not even left our home planet. Then came rockets that carried explorers into orbit, footsteps on the moon's dusty plains, and rovers crawling on neighbouring worlds. Each milestone seemed monumental in its day, yet each was just a prelude to the cosmic voyage that awaited. The invention of the warp drive, born from ideas once laughed off as fantasy, became the key that unlocked the starlit frontier. Now, looking back, those early achievements have a new context. They were the first steps of a child who would one day learn to run across the stars. It's astonishing how quickly the extraordinary can become ordinary. Today, a spacecraft jumping between star systems is as routine as an airplane flight was in centuries past. Schoolchildren casually discuss field trips to the moons of distant planets. A merchant on a far colony checks the day's market prices on Earth as easily as one might once check the next town over. Yet none of this could have happened without the audacity of generations who dared to believe in the impossible. We remember the visionaries, the scientists who laid the theoretical groundwork, the engineers who built the first warp engines, the dreamers and writers who imagined these journeys long before they could be real. Their legacy lives on in every voyage we take. What was once fiction became our reality, because we refused to stop dreaming. Beyond the tangible achievements, the ships, the colonies, the new technologies, lies perhaps the greatest legacy of faster-than-light travel, a profound shift in perspective. We discovered we are not alone in the universe, and in doing so, we found companionship and wisdom beyond our own species. We learned that cooperation can extend far beyond the bounds of Earth, encompassing beings of completely different origins. Humanity's sense of identity expanded. We see ourselves now not just as citizens of one planet or one nation, but as participants in a vibrant, galactic community. Our myths and philosophies evolved to include new constellations of meaning shared with other cultures among the stars. And we carry with us a humbling awareness. The cosmos is vast, and we are just one part of its grand design. Yet we have the privilege to explore and appreciate it. In daily life, reminders of this epic journey surround us. A young student in a colony classroom might recite the names of the first deep space explorers, the way previous generations recited names of great explorers of old Earth. Families living on a world orbiting a distant sun share stories passed down of the time when their ancestors first arrived, guided by the light of a dream. On Earth, an elderly person might look up on a clear night, spot the faint glimmer of a far-off star where humans now dwell, and marvel at how the boundaries of home have blurred into the infinite. For children born in this era, the idea that once we were confined to a single planet is almost beyond imagination, a distant chapter of history. They play with toy starships and draw pictures of alien friends without a second thought, inheriting a universe made larger and kinder by the efforts of those who came before. On every world, the anniversary of the first faster-than-light launch is now celebrated as a holiday, a day of unity and thanksgiving for the stars. On that day, each year, people gather outdoors under alien skies to honor the moment we took our first step into the galactic ocean, reminding themselves of how hope and daring made the universe a little smaller and the human spirit so much larger. Yet, for all we have achieved, the journey continues. The more we weave our lives into the cosmic tapestry, the more we realize there will always be further horizons. Perhaps one day we will venture beyond our galaxy to others unimaginably far away, or uncover deeper secrets of space and time that transform our understanding once again. Every answer we gain brings new questions. What other marvels await in the uncharted depths? How will our descendants, centuries from now, push the boundaries even further? The legacy of faster-than-light travel is not a closed book, but an open invitation, a call to keep exploring, to keep reaching for what lies just out of reach, as we have always done. And so, here we stand, builders of a dream that became reality, heirs to a future once only whispered of under starlit skies. The warp and weft of space has bound us to the cosmos and to each other. Every journey a new thread in the ever-growing fabric of our collective destiny. From the first tentative step across light years to the bustling community of worlds we now know, one truth shines brightly. Our capacity to dream, to imagine the impossible, is the beacon that guides us forward. Even now, as we gaze toward the next mysteries on the cosmic horizon, we carry that beacon with us. Our story continues, written in the light of distant stars, each chapter woven into the next. And as we voyage onward, faster than light, we keep alive the spirit that set us forth, the enduring hope that whatever wonders await in the darkness, we will find them together. Now, as we draw the final threads through the tapestry of our journey, we find that science and imagination have woven a pattern more wondrous than either alone. If we reach for the edges of the known universe, we feel both the weight of countless theories and the lightness of a dream. Each star we have studied, each thought experiment we have imagined, has become a thread. They crisscross and entwine, creating a tapestry that glows in our minds. It is a tapestry made of facts and dreams, mathematics and poetry, curiosity and courage. Every discovery, every question, was a colourful yarn, spun with humility and hope. In weaving these threads, our journey has become both a dream and a map, guiding us toward new horizons. Now we step back and admire the pattern we have formed, illuminated by the quiet glow of understanding. It reminds us that every moment of exploration, no matter how small, contributed to something grand. The tapestry is now complete, radiating with the light of all we have learned and hinting at wonders yet unseen. Here, at the end of our journey through ideas, we stand back and behold the full tapestry of our exploration. What was once a single thread of curiosity has become an entire cloth, woven together from many strands. Patterns now emerge, some formed by pure fact, others painted by dreams. The darkest mysteries are balanced by bright hopes. Science and imagination have interwoven completely, and the full design slowly comes into view. We can trace particular threads. One thread is the science of relativity, a principle that taught us space itself can bend and ripple. Another is the daring idea of a warp drive, a dream from science fiction now cast into equations by theorists. We even threaded the needle of quantum physics, touching on entanglement and the strange connections it hints at. Each concept added its colour to the cloth. Telescopes and spacecraft provided many golden stitches of observation. In each way we could, we sewed knowledge onto this grand pattern. Throughout this voyage, every discovery added richness. We peered at distant galaxies whose light had travelled for millions of years to reach us. We listened to the whispers of spacetime, gravitational waves that told us of stars colliding far away. We even imagined riding on a beam of light or surfing a ripple in space. Each idea, whether tested or still in the air of imagination, turned the tapestry more vivid. The threads of creativity and rigour grow impossible to separate. Beyond the bright threads of discoveries, there is also the subtle background that gives context to everything. Even the faint afterglow of the Big Bang, the cosmic background radiation, is like a silver thread running behind the scenes of our tapestry. It reminds us that every warp and weft in space-time has a story, that our cosmos has its own history woven into every direction we look. Of course, there are still threads we cannot see clearly. Dark matter and dark energy remain as shadows on the edge of our tapestry. They hint that there are more patterns, more colours yet to discover. We have woven what we can from light and reason. The rest remains tantalizingly out of reach, waiting for another day to be understood. Never have science and imagination been so entwined as on this journey. We allowed ourselves to dream of starships and faster-than-light voyages, and then turned those dreams into study and discussion. We drew pictures of what might be, and then used mathematics to check if the drawings could become real. Visionaries and methodical thinkers walked together. Every bold idea was met with questions, and every question with curiosity, a gentle dance of possibility and proof. Another important thread is humility. In the beginning, humanity thought Earth was the center of everything. As we have traveled through this understanding, we learned instead that our world is just one small thread in an immense tapestry. Each time we looked farther into space, our perspective grew wider. We learned that the sun, our star, is just one among countless others. And that knowledge made us both smaller and larger at once. Small in scale, but large in spirit, connected to the universe by these new threads of understanding. Looking back on how this tale unfolded, we see each section as part of the loom. We began by questioning why nothing can easily outrun light, and then ventured outwards with each new idea. We listened to the equations of Einstein, then entertained the bold solutions of modern physicists. We imagined warp bubbles and wormholes. In each step, we set down coloured threads. Now, with the final pattern before us, we recognise how each segment wove into the full cloth. At the start, these dreams were just that, dreams cast in the light of countless candles. Now they stand on equations and measurements as solid as pillars. We began with caution, we end with curiosity and confidence. What once felt out of reach has shaped our reality. We drew lines in the sand under the starry sky, and now follow those lines into the science of tomorrow. In this tapestry, every initial sketch of wonder became a clear thread of knowledge. This tapestry is not just the cold data of science, it is also a work of art. In weaving it, we discovered that each formula and equation can sound like poetry, each experiment like a brushstroke, each discovery like a brilliant colour. The beauty of the universe is not only in what we observe, but also in the patterns we have found. And perhaps beauty itself guided us, because even a formula can feel like a poem to the heart. And the greatest truth woven here is that all things are connected. The laws of the very large and the very small, the mythic and the measured, the real and the imagined, all blend into a single story. The moment we accepted the connection, many pieces of the puzzle fell into place. We feel, more than ever, that the universe isn't a cold machine, but a gentle companion. We are threads woven in the same cloth as stars and galaxies. We carry gratitude too. Gratitude for the scientists who spent their lives untangling equations, for dreamers who first dared to imagine such voyages, and for the cosmos that gave us clues through signals and light. Each piece of this journey was not made by one person alone, but by many hands and minds across time and space. Our tapestry owes its beauty to everyone who added a stitch. Even at the smallest scales, we found surprises. We learned about quantum entanglement, a strange bond between particles that Einstein once called spooky. It was as if two threads far apart on the tapestry could feel each other secretly. We knew this connection could not carry us faster than light, but it hinted that nature might weave in ways we do not yet fully see. This mystery added a deep texture to our tapestry, reminding us that wonder can arise even from the tiniest threads. We also peeked into the most daring dreams, wormholes and shortcuts through spacetime. For a moment, we held our breath, imagining tunnels connecting distant stars like doorways. But science reminded us these tunnels remain hypothetical, needing unimaginable materials to stabilize them. Still, even if we do not have keys to unlock these shortcuts today, the very idea danced in our minds. It is proof of how boldly our imagination threaded through the tapestry, coloring it with possibilities. In the midst of this weaving, the concept of a warp drive glowed brightly. We studied Miguel Alcubierre's equations, which suggested a bubble of bent space that could carry a ship faster than light. We listened to modern scientists who toyed with metamaterials and bubbles, striving to coax science fiction into reality. And we also learned of the challenges. The energy required was staggering, and the rules of physics stubborn. Yet the spark remained. In attempting the impossible, we found both inspiration and truth. One remarkable thread in our tapestry was the gentle vibrations of space-time itself. The ripples of gravitational waves, born in distant cosmic dances, were long predicted and finally heard by our detectors. We listened to their faint song and proved that even fabric itself can hum. That discovery filled our tapestry with sound, a triumph of perseverance. It reminded us that the universe loves to share its secrets with those who wait and listen. We also witnessed that the tapestry itself is expanding. The space between galaxies is slowly stretching, making the distant threads move away from each other. This cosmic expansion reminded us that while some destinations grow farther apart, the overall cloth only gets bigger. It gives us more canvas for our curiosity, more patterns yet to appear, even if some adventures require generations to begin. Our skills and technologies also became threads. We built great telescopes on Earth and in orbit that could gather more starlight than ever before. We launched space probes beyond our neighborhood. Voyager carried our song past the solar system. Satellites and rovers sent back stories from planets. Each instrument was a thread of inquiry, feeding our tapestry with real information. With every advance, from radio arrays to the newest space telescope, our view sharpened, and the tapestry took on more detail. Mathematics itself was a loom. The equations and formulas were patterns we learned to follow. They guided us on how rockets escape gravity, how light bends around stars, how satellites map galaxies. When we wrote an equation in a quiet room, We were actually stitching a design into our cosmic tapestry. Without math, our cloth would have been mere clouds. With it, the shape became clear. And we are reminded that this journey is not only science. Art and myth have their own threads here. Poets and painters have long admired those stars, and their inspiration guided our curiosity. Every science fact we found had its mirror in a story or a dream, and that made the tapestry resonate with more meaning. When science meets art in the same cloth, the result is deeper understanding and beauty. In many ways, this tapestry reflects us as well. Every idea we explored, every star we longed to reach, told us about our own human spirit. The cosmos became a mirror. By imagining travel among the stars, we confronted our desires and our limits. Each thread of knowledge was also a thread of hope, courage, and perseverance that lives within us. The tapestry we wove is as much a portrait of ourselves as it is of the universe. Our journey began in childhood wonder. It ended in adult understanding, but the thread connecting them never snapped. Recall how as children, we gazed at the sky and asked, "What if?" Now, grown older, some of us learned physics to answer those questions. The tapestry we made includes the amazement of a child and the precision of a scholar. These very different threads run side by side, showing that every mind, big or small, contributes to the whole. We have been travelers, not in actual ships, but in our minds. Though our chairs are still on Earth, we have visited worlds of pure thought. The pulse of a quasar, the shimmer of an alien sky, the spinning of a black hole. Each has been carried to us through dreams and equations. In many ways, these mental voyages are as real as any physical one. We allowed ourselves to be explorers of a different sort, and it has carried us to every corner of wonder. In the silent expanse of space, we found a gentle truth. Even the greatest explosions in the universe reach us only as faint light or whispering waves. The cosmos operates in its own time, but it also conserves a kind of peace. Understanding that quiet endurance is comforting. It reminds us that we are not threatened by the abyss, but cradled by it. In this realization, the universe feels like a calm companion, not a perilous void. Patience has been one of our greatest teachers. We waited decades for a signal, centuries for an answer. Still, each day we added a little more understanding. The tapestry took time, much more time than one human lifetime. But that did not stop our weaving. We were part of something bigger than ourselves, and patient dedication turned vast puzzles into gentle patterns. The future will continue with the same steady hands, adding yet more fine threads to this cloth. Let us not forget our own beautiful home in all this. Earth is one bright thread in the dark fabric, one speck of light among billions. Here, on this small blue orb, we created this tapestry of ideas. That perspective humbles and reassures us. No matter how vast the cosmos, our home remains precious, its beauty given weight by our understanding. It is the thread from which we started, and it remains woven at the center of the cloth. When we look at the night sky now, it feels like a tapestry hanging above us. Each star is a golden stitch, every constellation a familiar motif. Our journey can almost be traced among them. They seem to smile at us as we rest, because part of our journey has become part of them. In the quiet of the night, the cosmos itself tucks us in with light. Now, As we gently turn the loom's handle one final time, the threads hold firm under our touch. We have weaved an intricate story across time and imagination. Gently, we tuck our woven tapestry into the corners of memory, letting its quiet pattern glow. Tonight, these threads rest with the stars. Tomorrow's weavers will find this cloth ready, with more work to do. For now, we rest. As the tapestry settles in our hands, the loom that wove it remains at work. We pause at this threshold, feeling both the satisfaction of completion and the gentle promise of threads yet to come. What has been woven is profound, but the process continues. In each quiet moment, new ideas stir, new patterns begin to emerge. We now reflect on the path we travelled and look ahead with quiet wonder to the threads tomorrow might weave. It is strange to think that in this quiet night, we have travelled a winding path from the ancient wonder of looking up at the sky to the high mathematics of Einstein and beyond. We travelled not with feet, but with thoughts. Each idea took us farther, as if we were sailing on the cosmic sea of knowledge. We have followed starlight and equations together, letting each guide us onward. We remember how it all began, with simple questions asked by stargazers on long-ago evenings. Even with limited vision, our ancestors spun tales and made maps from the patterns in the sky. Those stories from long ago became the first golden stitches in our ever-growing tapestry of understanding. Their wonder lives on in every equation, every hypothesis that we have added along the way. It feels as if we have walked side by side with great minds. We heard the echoes of Galileo's telescope and Einstein's gentle smile as they looked up at the heavens, and we listened to authors and dreamers who charted courses through imaginary galaxies. All of these voices came together, half fact, half fable, and gave us courage to keep looking, to keep weaving. And yet, as we reach the turning of this page, the universe has already grown a little more. New eyes in space, gentle robots on distant worlds, even experiments hidden in quiet silence. Each one has the power to add new threads to our tapestry. The moment we learn one answer, the cosmos reveals another question, as if inviting us to dance on. The loom has not stopped. In the distance, dawn of discovery is already breaking. New generations stand up to peer through telescopes, feeling the wonder that once stirred in all of us. One day, someone might build what now seems impossible, and we will have helped unfurl the map that guides them. Our voyage through ideas has become part of the toolset of tomorrow's explorers. Perhaps we are changed by all this. We have learned to listen to the silence of the stars and to hear in it a gentle song. We have learned humility, that even the smallest discovery can be precious. Each answer came with humility, each new question with awe. We sense a kinship with those who look up from Earth at night, knowing what it means to wonder. In this calm moment of reflection, the cosmos feels a little less distant. We carry with us not just facts and figures, but a quiet joy. We carry the knowledge that our home on Earth is part of something magnificent. We learn to call the silence of space our companion, and the stars our old friends. Perhaps the most surprising lesson of all is that some questions are still beyond our grasp, and that's okay. We have learned patience. The cosmos reminds us that nature does not rush, and that understanding grows in time. Just because one chapter closes does not mean the story ends. Future dreamers and thinkers will add their threads to this tapestry. We have only begun to scratch the surface of these mysteries. Yet the warmth of knowing encourages us as we step away for tonight. We never walked this path alone. All around the world, people listened to the same cosmic symphony. Whether in great observatories or backyard telescopes, we felt connected by curiosity. Each mind added understanding, each question added colour. This journey was a conversation across continents and centuries, binding us together. That shared wonder is another golden thread in our tapestry, one that holds together all who look up in awe. We have grown in ways beyond understanding the cosmos. Facing these immense questions has reshaped us. It taught us humility, certainly, but also a comforting sense of belonging. When darkness falls and the stars appear, we feel ourselves part of that cosmic family. Each person listening carries a fragment of this journey, and together we create a community of dreamers and thinkers. That is perhaps the greatest reward of all. Already, new eyes are opening onto the cosmos. Advanced telescopes on Earth and in orbit, listening instruments gathering faint signals, and even concepts for tiny sail-driven probes bound for nearby stars. All these promise to add fresh threads to our tapestry. Each new mission, each new piece of hardware, is like a new colour ready to be dyed into our cloth. We can only imagine the subtle details it will reveal, just beyond the reach of today's grasp. For some, this feels like the end of one journey, but it is just a step on a path. We will awaken to new ideas tomorrow. The loom turns on, slowly weaving a new dawn from today's threads. We see even our own limits as opportunities. If we cannot travel one way, maybe we will find another. Each ending, after all, is an invitation to begin again. Tomorrow is unwritten, but our tapestry is ready for new weavers. Each discovery we made today lights the way for others. In the loom of tomorrow, every one of us may pick up a needle and thread. Whether as scientists or dreamers, or simply those who gaze at the sky, we all have a part to play. The patterns we create will be richer for what we have learned and imagined together. Perhaps one day, we may find others among the stars. That would be a thread more profound than any other. Even the very idea of contact with another form of life makes our tapestry richer, weaving questions of kinship among beings. For now, we can only dream of that possibility, but it reminds us how vast and full of potential our tapestry truly is. In the years ahead, people will look back on our journey as part of their own story. They will build on these threads and perhaps weave patterns we cannot yet foresee. We have given them a tapestry not yet complete, and they will continue the design. Thinking of that, we feel grateful to be part of such a grand story, one that stretches beyond any one lifetime. In chasing these mysteries, we found more than solutions. We found joy, beauty, and purpose. We discovered more about the universe and more about ourselves. The journey itself became its own reward. Every step taught us kindness, patience, and the value of questions. These are gifts we carry forward, woven forever into our tapestry. We now see the sky differently. What once was just a backdrop of twinkling dots has become a source of endless stories. The sunrises and sunsets remind us of the beginning and end of each day, as well as the endless cycle that the universe itself follows. Each star that glitters is no longer just light, but a teacher reminding us of knowledge and mystery. In our hearts, the sky now carries a familiar smile, not an unknowable face. The pace of our journey astonishes us. For eons, the stars kept their secrets, and only telescopes broke the silence. Then in just a few lifetimes, we built a robust tapestry of knowledge. It feels both like a heartbeat and a millennia. We have learned a great deal, yet each answer invites more time to explore. It reminds us that no matter how quickly the world moves, there is always room for new threads to be drawn. The universe was always whispering, but we had to learn its language. Only with patience and effort did we start to recognize its voice. Today, we hear star songs, see distant beacons, and understand the quiet hum of creation. It reminds us that understanding might arrive softly, but it is there for those who listen. We can almost hear the fabric of space and time telling us to keep exploring, even as we close our eyes tonight. Imagine this tapestry as a map of exploration. Each thread marks a star or a concept. We have charted many of these points. We know how fast light travels, how gravity tugs, where black holes lurk, and how space can bend. Each step we took laid down new coordinates for others. The map we made will guide future travelers, whether they find faster engines or smarter ways to dream of moving through the vastness. We learned that no discovery is too small. A single photon captured by a telescope or a tiny particle measured in a lab can illuminate an entire path. Like the smallest threads, these details held up larger patterns. Every piece of data mattered. We reminded ourselves that, in a tapestry, even the faintest thread can complete the picture. In that lesson, we found wonder too. Now, as twilight deepens on our journey's horizon, we pause in gratitude and peace. The loom of our story is quiet for tonight. Soon, we will turn to rest and bid a gentle goodnight to the stars, carrying hope for the dawn to come. In this final quiet, the stars themselves seem to sing a lullaby. They have been our silent companions throughout this journey. Now they glow softly as we close our eyes. Let us whisper a gentle goodnight to the cosmos and drift into dreams under its light. Perhaps we recall a favorite moment from this voyage, a single idea or a distant star that inspired wonder in us. Let this memory carry us into sleep. There is peace in letting our thoughts wander among the galaxies one last time tonight. Imagine yourself lying on a gentle earth, the night sky open above like a quiet ocean of lights. You can feel the comfort of this moment as the cosmos embraces you in its soft hug. Let each breath synchronize with the slow pulse of the universe as you settle deeper into rest. As your eyes grow heavy, know that the stars remain steadfast overhead, unchanged by our slumber. The universe continues its calm dance as you dream. You are safe, cradled by the vast quiet of space, ready for rest. Above you, stars blink in quiet encouragement. Each one seems to say, "Sleep well." Let their distant sparkle be a soft lullaby. The night sky cares for you as tenderly as a mother hums a tune. If your thoughts wander, allow them. Let them turn into gentle visions. Maybe you're sailing silently in a spaceship, coasting among the planets. The cosmos around you is calm and safe, welcoming you as one of its own. Feel the rhythm of your breathing slowing down, matching the night's own steady pace. Each breath is a gentle wave on the still sea of dark. Inhale peace. Exhale any remaining tension. With each breath, sink a little deeper into rest. Picture the moon overhead, if it is up, a silver coin in the sky. Its gentle light cushions your dreams. Even if it is hidden behind clouds, know that its soft glow still watches over you, pulling you toward calm sleep. Now think of all the places your mind has traveled in this series, from faraway galaxies to the smallest particles. Let them rest now. Each wonder you explored was like a star in your personal sky. Tonight, they join you in sleep, twinkling gently in your dreams. The galaxies will continue their slow spin while you rest. Comets and meteors will continue their journeys. All that we observed is patient, waiting for you to return with fresh eyes tomorrow. For now, it shines quietly in the dark, just for you. You have earned this peace. Through questions and wonder, you have journeyed. Now, your journey ends for the night. Rest easy, knowing the cosmos is calm and safe. All is as it should be. Even as darkness deepens, remember each night is part of a cycle. After darkness, light will come. But for now, darkness is kind and forgiving. It gives rest to all. Let your eyelids grow heavy. The weight of your thoughts is lifted, replaced by tranquility. You are drifting away, cradled by dreams. We will be still now, breathing softly. You will not even notice the moment you drift off. This is not the end, but the sweetest rest.